Above our heads, the sky looks calm, blue ceiling by day, a field of stars by night. But hidden beyond that familiar view lies a place unlike anything we know, a thin, invisible frontier where the air fades. The light bends, and Earth itself seems to end. It's a world without sound, where flames burn green, where satellites drift through silent storms, and where the line between life and nothing dissolves into black. From the first daring balloon ascents to the Voyager probes still traveling into interstellar night, humanity has spent centuries chasing this boundary. But what if the edge of space isn't an edge at all? What if it's a mirror, showing us how fragile and how infinite our world truly is? There is a place above us where the sky forgets to be blue, where the wind slows until it cannot move at all, and where the world below begins to look like a curved memory pressed against a vast black ocean. Scientists call it the Kármán line, and they measure it at 100 kilometers above sea level. A number that seems precise, but is, in truth, only an agreement between minds trying to draw a border on something that has no edges. It is where Earth's air becomes too thin for wings to lift a plane, where the pull of the atmosphere weakens, and the laws of flight give way to the laws of orbit. It is not quite heaven. It's a not quite Earth, an invisible boundary that holds the weight of both science and wonder. For centuries, humans could only imagine what lay above the clouds. The ancients looked up and believed the sky was a dome of light or a sea carried by gods. Even when hot air balloons began to rise in the late 18th century, the airmen could go no higher than a few kilometers before the cold and thin air forced them down. The dream of reaching the edge of space belonged, for a long time, to fiction and fantasy. But as the 20th century unfolded, and wars pushed technology further than imagination once dared, we began to build machines and suits strong enough to test the ceiling of the sky itself. It was no longer a question of whether man could rise that high, but of how much his body and his mind could endure before the silence above swallowed him. In 1931, Auguste Piccard, a Swiss physicist, and his assistant Paul Kipfer rose in a pressurized balloon over the Alps, reaching a record altitude of 15,781 meters. From that height, Piccard described the world as a great flat disk with a sharply defined blue circle, and above it a dark, almost violet sky that hinted at the void beyond. He had glimpsed something no one before him had truly seen: the thinning of the atmosphere, the line where sunlight ceased to scatter and began to fall unbroken. His ascent was both a scientific experiment and a symbolic crossing, for he had brought the human eye close enough to space to see its face. 3 decades later, another man would take that encounter further. In August 1960, an American Air Force officer named Joseph Kittinger rose, alone in a helium balloon, to 102,800 feet, nearly 31 kilometers above New Mexico's desert floor. His mission, part of Project Excelsior, was to test how a pilot might survive an emergency ejection at extreme altitude. The ascent took more than an hour, and as the balloon climbed, the air around him faded into black, and the curve of the earth became visible beneath his boots. When he finally stepped out, he stood at the edge of the known world, suspended in near vacuum, the only sound his own breathing in the helmet. Then he jumped. In that fall, he became a bridge between the atmosphere and the cosmos, between gravity's pull and the human will to test its limits. The Kármán line, named after the Hungarian-American engineer Theodor von Kármán, was not yet an everyday phrase, but it already described the invisible transition that Kittinger and others would experience. Von Kármán had calculated that around 100 kilometers above Earth, the air was too thin for conventional flight, and that a vehicle there would need to move so fast to stay aloft that it would effectively be orbiting. In other words, flight and spaceflight were separated not by a wall or horizon, but by a point where physics changed its rules. To reach that height was not to leave Earth entirely, but to enter a realm where human definitions began to blur. Even today, that boundary remains more concept than line. The atmosphere stretches far beyond it, thinning gradually until it merges with the solar wind. The International Space Station orbits at about 400 kilometers, and faint traces of air molecules can still reach that high, brushing against its panels like whispers from below. Yet for storytellers, explorers, and engineers, the Kármán line endures as a marker of first the point where aviation ends and astronautics begins, where the sky no longer holds you and the planet starts to let go. From that height, the world below looks silent, immense, and fragile. The deserts are pale streaks, the oceans a slow-turning blue disk, the clouds like threads of light. There is no sound, no wind, and no horizon in the way we know it, only a gradual fading of color. From pale azure to indigo to black, those who have seen it speak of a quiet awe that silences even fear. It is said that when the first astronauts crossed this invisible line in the early 1960s, they fell into an almost reverent stillness. The radio chatter stopped for a moment, and all that remained was the sight of Earth itself, a sphere of life floating in darkness, surrounded by nothing and everything at once. What lies at the edge of space is not a wall or a gate, but a shift in perception. It is where human breath, machine design, and imagination all begin to tremble under the same truth, that we are held close to this planet by a film of air no thicker, in proportion than the skin of an apple. Beyond it stretches the unknown, vast and unmeasured. And yet, every ascent from Picard's brass capsule to Kittinger's jump to the rockets that followed has begun the same way, with someone looking up at a sky that grows darker, feeling the pull to see where blue ends and black begins, long before rockets broke through the upper air. There were men and women who tried to climb toward the edge of space using the fragile tools of fabric, aluminum, and breath. Their journey was not into the void itself, but into the region where the air grows thin, where a single mistake could turn the sky into a tomb. The pursuit of altitude was driven by curiosity at first, then by science, and finally by the quiet rivalry of nations that wanted to see farther, fly higher, and look down upon the Earth from where few had ever been. What began with weather balloons in the early 20th century would, by mid-century, evolve into high-altitude planes and pressurized suits designed to carry the human body where the body itself was never meant to survive. At the start, it was the meteorologists who reached for the upper atmosphere. In 1898, the first unmanned weather balloons were released in France to measure pressure and temperature far above the ground. And over the following decades, scientists around the world sent paper-thin balloons upward, watching them vanish into the sky like fading stars. These early flights carried thermometers, barometers, and sometimes small cameras sealed in tin cases. And they taught humankind that the air above us is layered and cold and endlessly restless. By the 1930s, these unmanned instruments had reached altitudes of over 20 kilometers, brushing the edge of the stratosphere. Yet even as these fragile machines returned valuable data, there were always a few who wanted to see with their own eyes what lay above the clouds. In May 1931, Auguste Piccard, the Swiss physicist and balloonist, built a pressurized gondola from aluminum and glass and attached it to a hydrogen balloon larger than a cathedral. Together with his assistant Paul Kipfer, he ascended from Augsburg, Germany, and reached an altitude of about 16 kilometers. Inside the tiny sphere, Piccard peered through a porthole and saw the sky turn from blue to deep indigo. While the curvature of Earth became visible for the first time to human sight, he described the experience in measured scientific language. But there was wonder beneath the words, a realization that he had entered a part of the world untouched by wind or sound. The experiment proved that a sealed cabin could protect its passengers from the deadly thinness of high air, but it also revealed how fragile such protection was. Outside the sphere, the pressure was so low that water would boil at the temperature of ice, and the cold was beyond comprehension, minus 70 degrees Celsius, perhaps colder. A failure of the shell would have meant instant death. The race for altitude continued, especially as nations began to see the strategic value of the upper atmosphere. During World War II and the years that followed, military research pushed the limits of flight even higher. Jet engines replaced propellers, and new alloys allowed wings to endure the freezing vacuum of the stratosphere. Pilots spoke of the world beneath them, shrinking into abstraction, a patchwork of colors fading into curvature. In the 1950s, the Lockheed U-2 reconnaissance aircraft was developed by the United States, capable of flying above 21 kilometers. so high that it could slip above radar and watch entire nations unfold beneath its cameras. The men who flew these missions described a silence that felt almost sacred, a loneliness so complete that it could not be compared to anything on Earth. They wore pressure suits that hissed faintly with oxygen, their visors reflecting a black sky even at noon, and they learned to move slowly. Because a sudden breath or gesture could fog the glass or freeze the moisture in their own lungs. A decade later came the SR-71 Blackbird, an aircraft that could reach altitudes above 85,000 feet and speeds exceeding 3 times the speed of sound. Pilots such as Major Brian Schule, who flew it in the 1970s, spoke of watching the curvature of Earth with each passing minute, the blue band of atmosphere thinning until it looked like the faint edge of a bubble enclosing the planet. From that height, the sun rose in silence, and the stars were visible even in daylight. The Blackbird's titanium skin would glow from friction, yet inside the cockpit the pilot sat in a pressurized shell where the temperature could drop below freezing. Every system was designed to separate the human body from the lethal simplicity of the sky around it. The physiological dangers were constant and merciless. Above 12 kilometers, the air pressure is so low that without protection, the moisture in the lungs would evaporate in seconds, and the blood would begin to boil, not from heat but from the absence of pressure to keep it liquid. The condition, known as ebulism, was well documented by medical researchers who tested pressure chambers in the 1950s. Unprotected skin would swell grotesquely, and consciousness would fade almost immediately. Even the simple act of breathing would destroy the lungs as gases expanded uncontrollably. To survive these heights, flight crews wore layers of insulation and rubberized suits fed by oxygen tanks, their faces enclosed in gold-tinted visors. In photographs from those years, they look less like aviators and more like early astronauts, their humanity hidden behind the equipment that kept it alive. What united these early explorers scientists, pilots and engineers alike, was a shared fascination with the point where air could no longer hold life. Each ascent brought them closer to understanding how narrow the boundary was between existence and absence, between the breath that sustains and the silence that waits above it. They mapped the invisible territories of wind, pressure, and cold, and each experiment built the foundation for the rockets that would later climb beyond all air entirely. Before the space age truly began, there were these breathless heights, this region of thin blue air where man first learned the cost of touching the edge of space. And though technology has since carried us higher, those who flew there first remain suspended in history, forever balanced between the living Earth below and the infinite quiet above. When people speak of the edge of space, they often imagine a sharp border drawn somewhere above the clouds, a place where the air suddenly stops and the stars begin. But in truth, there is no such line. The sky does not end in any sudden way. It only thins, fading so slowly that even science struggles to decide where one thing becomes another. What we call space is not a separate place hanging above us, but a continuation of the air, stretched until its particles grow so few that they can travel kilometers without touching one another. The Earth's atmosphere does not stop, it simply forgets to stay dense. And as it forgets, it disappears into nothing. Scientists have tried for over a century to measure where that disappearance happens. Yet every definition leads to another question. Some say space begins at 80 kilometers above sea level near the mesopause, where the temperature drops to its coldest point about -90 degrees Celsius, and where air becomes so thin that an aircraft's wings lose nearly all lift. Others argue for a rounder, more symbolic number, 100 kilometers, the Kármán line, named after Theodor von Kármán, a Hungarian-American engineer who studied how fast an aircraft would need to travel to keep flying in such thin air. His calculations, made in the 1950s, showed that beyond that height, a plane would have to move at orbital speed to generate enough lift, effectively turning from an aircraft into a spacecraft. It was a practical distinction rather than a physical one, but it became a convenient threshold for international definitions of spaceflight. When pilots or astronauts cross 100 kilometers, they are often awarded their astronaut wings. though the air above 80 kilometers already behaves like the near vacuum of space. The confusion arises because nature rarely draws boundaries the way humans wish it to. Between the stratosphere and the exosphere, there is no line to see, no moment when the air changes its name. The atmosphere fades through layers, the mesosphere, thermosphere, and exosphere, one thinner and more elusive than the last. Even 200 kilometers above Earth, faint traces of air remain, enough to tug gently on satellites and cause their orbits to decay over time. The International Space Station, which circles at about 400 kilometers, still experiences drag from molecules of oxygen and nitrogen that drift like ghosts, invisible yet persistent. Farther out, perhaps at 10,000 kilometers, those same particles merge with the solar wind, forming the planet's final breath before it dissolves into the emptiness between worlds. It is strange to think that we live beneath something that has no clear ceiling, that the blue we see every day is not a surface, but a gradient that never truly ends. The color of the sky itself is a lesson in this fading. At sea level, the air is thick enough to scatter sunlight in every direction, filling our vision with blue, but as one climbs higher, the light has less to scatter from. By the time a pilot reaches 20 kilometers, the blue has deepened into indigo, and at 50 kilometers, it is nearly black. Yet there is still air, they're just thinner, colder, more transparent. The stars begin to appear even before space has begun, their light shining through the last shreds of atmosphere that once carried sound and weather and breath. This gradual fading challenges our need for borders. Humans have always drawn lines to make sense of the infinite, the horizon that divides sky from sea, the equator that cuts the world into halves. The imaginary circles of longitude and latitude that turn a sphere into a map. The Kármán line is another of these invisible marks, drawn not by nature, but by agreement. Symbolic gesture that turns an endless transition into a measurable frontier. Without such lines, it becomes difficult to claim, to record, or to remember. A nation can point to a border and say, "This is ours," but it cannot point to the thinning air and say, "Here, space begins." The edge of space remains untamed, not by law or ownership, but by indifference, does not care to be named. When early balloonists like Auguste Piccard rose into the stratosphere in the 1930s, they were among the first to describe the sensation of being between worlds. Through their portholes, they saw the curve of the Earth wrapped in a blue halo that faded upward into darkness. There was no boundary they could point to, no barrier they could cross. It was simply a place where the Earth began to loosen its hold. Later in the 1960s, pilots flying U-2 and X-15 aircraft reported the same thing, that somewhere around the edge of space, the world below seemed to vanish into distance while the stars came alive in full daylight. Their instruments could tell them their altitude, but their eyes could not find where Earth ended and the void began. Even today, satellites and space agencies define the edge of space differently. NASA sometimes counts 80 kilometers as the limit, following the older definition used during the X-15 program. The Fédération Aéronautique Internationale, which certifies flight records, still favors 100 kilometers. Yet neither number captures what actually happens up there. The atmosphere, after all, does not care about metrics. It cares only about the slow dance between gravity and sunlight. Earth's gravity tries to hold the air close, while the heat of the sun tries to scatter it away. And somewhere between those two forces lies a delicate, invisible balance that never stops shifting. When you look up on a clear day, you are seeing into a gradient that connects you to the stars. Though your eyes stop long before the connection does, the thinness begins not at a specific height, but everywhere above you, spreading upward like a whisper that grows softer until it is silence. That silence, that imperceptible fading, is the real edge of space-and, edge that is not a place, but a process. And perhaps that is why it remains so mysterious, even now. We draw our lines not because the universe demands them, but because we do. We cannot bear the thought that there are things without boundaries, so we invent them. Yet above all those invented borders, beyond the last faint breath of air, the Earth continues to blend into the endless dark, neither starting nor ending, only dissolving into everything that waits beyond. There is a height above the world where the wind no longer sings, where the air grows so thin that it cannot carry sound, and where movement itself becomes invisible. This is the realm of the upper atmosphere, placed between Earth and space that lies beyond the reach of weather, yet beneath the emptiness of the void. It is neither calm nor still, for countless unseen forces flow through it. But they do so without noise or weight, like light passing through glass. Those who study this region call it the mesosphere and the thermosphere, two layers that form a kind of borderland where the last whispers of Earth's air begin to meet the beginning of space. Here, temperature and pressure behave like opposites, and light becomes the only storyteller left. The mesosphere begins roughly 50 kilometers above sea level, a band so high that even the tallest clouds and strongest storms never touch it. At its base, the temperature falls steadily, colder than anywhere else in the atmosphere, reaching nearly -90 degrees Celsius at its upper boundary. Air molecules are sparse, scattered so thinly that a human climbing that high would suffocate in seconds. Not from lack of oxygen alone, but because the lungs would find nothing left to grasp. Yet despite its stillness, this is a layer of constant activity. Meteors that enter the atmosphere from space first encounter this region, and in their brief passage, they ignite into streaks of light that flash across the night sky. Every shooting star ever seen is a small visitor from the void meeting the resistance of the mesosphere, its friction heating the air around it into fire. The light we see is not the meteor itself burning, but the air responding to its intrusion, glowing in a thin, wordless protest before both vanish. Above the mesosphere lies the thermosphere, beginning around 80 kilometers and extending to nearly 600. Here, the temperature rises again, an unexpected reversal that puzzled early scientists. In this region, a few particles of gas absorb intense radiation from the sun, and though there are too few to warm anything tangible, they can reach temperatures above 1,000 degrees Celsius. Yet if one were to float there, it would not feel hot at all, for there are not enough atoms to transfer heat to the skin. It is a paradoxical world of invisible fire and impossible cold, where warmth exists without touch and energy without sound. This is also where the auroras live, those shifting curtains of green and red that dance across polar skies. They are born from collisions between atoms of the upper atmosphere and charged particles from the sun, guided by Earth's magnetic field into shapes that ripple and fold like silk in a wind that cannot be felt. The aurora is one of nature's quietest performances. There is no roar, no crackle, not even a whisper, though the light moves as if it were alive. To those who have stood under it in the Arctic or Antarctic night, it feels as if the heavens have drawn their own breath. The first scientific records of auroras date back centuries, but long before that, northern peoples spoke of them in story spirits of ancestors. Foxes brushing their tails against the snow, or warriors' armor flashing beyond the clouds. In 1621, French scientist Pierre Gassendi gave the phenomenon its name, combining the Roman goddess of dawn, Aurora, with Boreas, the Greek god of the north wind. Even then, the idea of light without sound seemed miraculous. Today we know that the glow comes from atomic collisions, oxygen emitting green and red light, nitrogen shining blue and purple, but knowing does not diminish the feeling of wonder. For in the silence above the wind, even science seems to speak softly at certain times of year. When solar storms strike Earth's magnetosphere, the auroras grow brighter and spread farther south, visible even from places where night skies are rarely dark. In March 1989, a geomagnetic storm caused by a massive coronal ejection from the sun produced auroras seen as far south as Texas and France. Power lines crackled, satellites trembled, and yet high above the sky shimmered in silent brilliance. The thermosphere had become a painting of charged light, a reminder that the calm we see is only the surface of greater forces at work. The particles that create those lights travel from the sun's surface in less than 2 days, crossing 150 million kilometers to collide with atoms that drift above our world. Every color is the record of that meeting, a cosmic handshake turned into radiance. What makes this region of the atmosphere so haunting is not its danger or its mystery alone, but its quiet. Below, the world hums with motion. Oceans churn, winds howl, trees sway, and cities pulse with mechanical rhythm. But up there, none of that sound survives. The thinness of the air means vibrations cannot pass from one molecule to another, and so even the greatest storm would move in perfect silence. A meteor could slice through the sky faster than any bullet, and not a single human ear would hear its passage. The aurora could fill the heavens with light bright enough to read by, yet it would make no sound at all. It is a part of nature that does not need voice to exist, and perhaps that is what gives it its power. For centuries, poets and scientists alike have looked at that quiet glow and found in it something human, an echo of thought, of emotion, of the small sparks that occur inside the mind. The upper atmosphere, in its silence, mirrors something within us, a space where meaning is felt rather than heard, where energy becomes color and memory becomes light. Above the winds that shape our world, there is a stillness that belongs to no country, no name, and no time. There, in the rare air where sound has vanished and only light remains, the sky ceases to be weather and becomes something closer to eternity, a place where even the faintest flame can shine forever without making a sound. Every night above the quiet world, tiny fragments of stone and metal fall from space, invisible until they meet the thin upper air and burst into light. They come from the cold regions between planets, from broken comets and shattered asteroids, from the debris that has circled the sun for billions of years, and when they touch the edge of our atmosphere, they create the fleeting streaks we call shooting stars. These lights are not stars at all, but the brief deaths of dust and rock meeting resistance for the first time in eons. Most are smaller than a grain of sand, yet when they strike the atmosphere at speeds exceeding 40 kilometers per second, the friction is enough to heat the surrounding air into plasma. For an instant, they become fire that falls from heaven, a celestial spark that never reaches the ground, erased before it can leave a mark. The Earth is constantly bombarded by these visitors, nearly 100 tons of material every day, but almost all of it burns harmlessly in the upper layers of the sky. It is only in rare moments that a larger fragment survives the descent long enough to remind humanity of what truly drifts above. The thin veil of air that protects us, stretching only a few hundred kilometers, is all that stands between the living surface and an endless field of drifting stone. That veil is fragile, yet it has endured every strike since the world began. In the mesosphere and thermosphere, where the atmosphere grows thin and the temperature shifts unpredictably, meteors meet their end in silence. Their speed compresses the air before them into sudden heat, and the shock wave tears the object apart, scattering incandescent fragments across the sky. What we see from below the bright lines, the falling sparks. The quiet vanishing's only the visible trace of destruction happening far above. Sometimes, though, that destruction does not finish quickly enough. On June 30th, 1908, a massive explosion shook the remote forests of Siberia, flattening 80 million trees across more than 2,000 square kilometers. The event occurred near the Tunguska River, and though no impact crater was ever found, eyewitnesses described a fireball crossing the morning sky before a blinding flash turned the horizon white. Moments later came a shockwave that shattered windows hundreds of kilometers away, and hours after that, strange glows were seen in the night sky across Europe. Scientists who investigated years later concluded that the explosion was caused by a meteor or comet, a fragment about 50 meters wide, which had entered the atmosphere at tremendous speed and disintegrated at an altitude of perhaps 8 kilometers. The blast released energy equal to 15 megatons of TNT, nearly 1,000 times greater than the atomic bomb dropped on Hiroshima. The trees beneath it were leveled in a pattern that radiated outward from a single point. Their trunks stripped bare, their tops burned, but not ignited. It was the largest natural explosion in recorded history, and it served as a reminder that the shield above us, while powerful, is not infallible. For more than a century, Tunguska remained an eerie mystery. Expeditions were slow to reach the site, delayed by the isolation of the Siberian taiga and the difficulty of travel. The first serious investigation, led by Leonid Kulik in 1927, found no meteorite fragments, no crater, only vast stretches of scorched earth and trees lying like matchsticks. The locals spoke of the sky opening, of the air catching fire, of reindeer and villages destroyed by heat alone. Scientists later reconstructed the event using computer models, showing how the object likely exploded in midair, releasing its energy downward in a cone of pressure. The atmosphere, in absorbing that energy, had once again saved the world from far worse. A similar but smaller warning came more than a century later. On February 15, 2013, when a glowing fireball appeared over the Russian city of Chelyabinsk. It was morning, the sky clear. Thousands of people saw the light streak across the sky before it exploded high above the city. The shockwave broke windows, damaged buildings, and injured more than 1,500 people, mostly from shattered glass. The meteor, about 20 meters across and weighing over 10,000 tons, entered the atmosphere at nearly 60,000 kilometers per hour and disintegrated around 30 kilometers above the ground. It released the energy of roughly 500 kilotons of TNT, 30 times greater than the bomb dropped on Hiroshima. Yet once again, Earth's shield had done its work. The air had absorbed the impact, spreading the force outward before it could reach the surface. The fragments that survived were small, most no larger than pebbles, scattered across the frozen steppe and recovered later by scientists who traced their chemical makeup to the stony class of meteorites known as Cond. Between these great events are quieter ones, the meteor showers that arrive with the rhythm of the seasons. Each year in August, the Perseids cross the night sky, born from the debris of Comet Swift-Tuttle. In December, the Geminids blaze through, created not by a comet, but by an asteroid, 3,200 Phaethon, whose path brushes close to the sun. On those nights, thousands of tiny fragments strike the atmosphere, and the heavens seem to rain with light. People gather to watch, lying on rooftops and fields, counting streaks as if the sky were writing in brief, luminous sentences. Each streak marks a collision between the infinite and the fragile, between the void and the thin, protective skin of air that makes life possible. If one could stand at the height where these meteors burn, the sight would be otherworldly. The flashes would be silent, the colors vivid orange, green, and white arcs dissolving into faint trails that glow for only seconds. The sound would come later, far below, as faint rumbles carry down through denser layers of air. It is a kind of conversation between Earth and the cosmos, one spoken in light and answered in stillness. The atmosphere acts as a shield, but it also serves as a stage, transforming destruction into beauty. What should have been impact becomes radiance. What should have been violence becomes spectacle. And so, when we look up and see a meteor pass across the night sky, we are witnessing not a beginning, but an ending. A fragment that has traveled millions of kilometers ends its journey in a brief shimmer of heat, erased by the same air that keeps us alive. The thin blue line above the Earth, fragile as it seems, is enough to burn away the universe's sharp edges. Every flash of light is proof that the sky still keeps watch, that the world beneath it remains safe beneath its invisible shield, and that even in silence, the heavens continue to guard the earth with fire. There is something almost childlike about the image of a balloon rising through the sky, its thin skin straining against invisible pressure, climbing higher and higher until it seems to vanish into nothing. Yet for more than a century, that simple image has carried some of humanity's greatest ambitions, transforming a toy of air into a vessel for science, exploration, and courage. The story of high-altitude ballooning is one of fragile fabric and quiet bravery of pursuit that brought us closer to the edge of space. Long before rockets or capsules existed, every ascent began in silence, on calm mornings when the wind held its breath, and every mission carried within it the same question: how far could something so delicate go before the sky refused to hold it? The earliest attempts were clumsy but astonishing for their time. In the late 18th century, the Montgolfier brothers in France sent their paper balloons drifting into the air, powered by the smoke of burning straw. Their inventions rising only a few hundred meters, but capturing the imagination of an age just beginning to look upward. By the early 20th century, the technology had grown more precise and the goals more daring. Scientists began building balloons from varnished silk and rubber, filling them with hydrogen and later helium. To reach altitudes where instruments could measure the properties of the atmosphere, the air grew thinner, the temperatures colder, and the risk greater, yet curiosity outweighed fear. By 1931, Auguste Piccard, a Swiss physicist, had ascended to more than 16 kilometers in a pressurized aluminum sphere. Becoming the first human to see the curve of the Earth with his own eyes, his capsule was cramped, barely large enough for two men and their instruments. And yet within it lay the seed of modern spaceflight. The idea that a human being could survive in an enclosed, pressurized environment high above the breathable world. Over the decades that followed, balloons became laboratories suspended in near space. The thin film of plastic or polyethylene that held them aloft could stretch over 100 meters in diameter when fully expanded. The material so delicate that a fingernail could tear it, yet strong enough to hold thousands of cubic meters of helium. They lifted telescopes, cameras, cosmic ray detectors, and entire gondolas of scientific equipment into the stratosphere, where the air is calm and the view unbroken by clouds. In the 1950s and 60s, NASA and the U.S. Air Force launched hundreds of such balloons under programs like Project Manhigh and Project Excelsior, each one testing the limits of endurance and human physiology. In August 1960, Joseph Kittinger climbed to 102,800 feet beneath one of these great white orbs and stepped into the void, falling back to Earth in a record-breaking skydive that made him, for a few breathless minutes, the highest falling man in history. The balloon that carried him was barely visible against the black sky, a fragile in the thin air between life and silence. In the decades that followed, the pursuit of altitude through balloons became more refined, though no less ambitious. NASA continued to launch high-altitude research balloons from places like Fort Sumner, New Mexico, and McMurdo Station in Antarctica. Their instruments designed to study cosmic rays, ozone levels, and the faint traces of radiation that drift between the stars. These balloons often stayed aloft for weeks, floating at altitudes of 35 to 40 kilometers higher than any airplane could fly. From those heights, the horizon bent into a graceful curve, and the atmosphere below glowed with a pale blue halo. To the cameras and sensors suspended beneath, the Earth appeared both infinite and impossibly small, a living world wrapped in a layer of air no thicker, in proportion, than a coat of paint. Then, in October 2012, the world watched as a new kind of balloon ascent captured both the spirit of adventure and the quiet terror of fragility. Felix Baumgartner, an Austrian skydiver working with Red Bull Stratos, rose into the sky from the New Mexico desert in a capsule attached to a massive helium balloon. His goal was to become the first person to break the sound barrier in freefall. But what made the mission remarkable was not just the leap itself, it was the ascent. For over 2 hours, the balloon climbed higher, expanding slowly as the pressure outside dropped, its silver film growing thinner and wider until it looked like a second moon suspended above the desert. Inside the capsule, Baumgartner's voice grew calm and distant as he reported passing through 50,000 feet, then 80, then 100. At around 128,000 feet, or nearly 39 kilometers, the sky outside had turned completely black, and the earth below shimmered in brilliant curvature, clouds stretching like white veins over the continents. The balloon, barely visible from the ground, carried both a man and a nation's gaze into the realm where only silence exists. When he finally opened the hatch and stepped out, the scene was beyond comprehension. He was no longer standing on Earth but hanging above it, the planet a blue sphere beneath his boots, the stars motionless in a vacuum-like stillness. His last words before the jump, "I'm going home now," echoed across radios. And then he fell, tumbling through the near-space air until friction caught him, heating his suit as he passed the speed of sound. The balloon that had carried him, light as a whisper, drifted on a little longer before collapsing into the cold sky, its task complete. What remained was not the record alone, but the image of human vulnerability suspended in the void fabric, helium, in courage holding together against nothingness, every high altitude. Balloon flight carries that same paradox. the meeting of immense ambition and delicate design. The materials are measured in microns, the payloads balanced to within grams. And yet they endure forces that would crush or tear apart anything less precise. A single tear in the film, a stray gust of wind, or an imbalance of heat could end the mission before it begins. The higher the balloon climbs, the larger it swells, until at last it expands beyond its strength and bursts, scattering fragments that drift back down through the atmosphere. Each mission ends the same win, silence, in falling. In return, but what it leaves behind is knowledge. Readings of cosmic radiation, maps of atmospheric currents, glimpses of ultraviolet light that never reaches the surface. There is a poetry in this pursuit. In watching something so fragile rise towards something so infinite, the thin line of helium and plastic becomes a symbol of how close we can come to the edge without crossing it. How much wonder can be held by a thread? When the balloon reaches its highest point, the world below turns silent and curved, and above it stretches the blackness of space. For a few moments, human hands touch the unknown. And though the ascent always ends in descent, what remains is the reminder that even the lightest things can reach the stars, if only for a while. There was a time when the sky was no longer seen only as a place of weather and wonder, but as a battlefield waiting to be claimed. After the Second World War ended in 1945, the world's most powerful nations began to look upward, not only with curiosity, but with suspicion. The Cold War had begun. The invisible boundary above the clouds where air thinned and gravity loosened became a new frontier for dominance. The competition between the United States and the Soviet Union stretched from the depths of the oceans to the edge of space itself. And in that race for control, the sky transformed into a silent arena where technology and secrecy replaced open combat. From the late 1940s through the 1960s, the push for altitude became a contest of innovation and fear, with each nation trying to see farther, fly higher, and strike faster than the other. At first, it was reconnaissance that drove this strange new war. The invention of the atomic bomb had changed everything, and by the early 1950s, both sides were desperate to know what the other was building. The higher a plane could fly, the safer it was from interception, and the farther it could see across enemy borders. In 1955, the United States began developing the Lockheed U-2, a sleek silver aircraft with wings so long and thin they seemed more like those of a glider than a war machine. It could reach altitudes of over 70,000 feet, soaring well above conventional radar, and from that height it photographed entire nations. Its cameras capable of reading license plates from the edge of the stratosphere. The U-2 became the silent eye of the Cold War, flying over Soviet territory under the belief that it was untouchable. That illusion shattered on May 1, 1960, when pilot Francis Gary Powers was shot down over Sverdlovsk by a Soviet SA-2 missile. His capture and public trial revealed to the world that the race for the upper sky was no longer just technological, it was political. Each flight risked not only a life, but an international crisis. After the U-2 incident, the race for altitude only intensified. In response, engineers at Lockheed's secret Skunk Works facility in California began developing a faster assorted life flying aircraft, the SR-71 Blackbird. By the mid-1960s, it could fly at more than 3 times the speed of sound and at altitudes exceeding 8,000 to 5,000 feet, its titanium skin glowing from frictional heat. Pilots like Brian Schul and Major Ed Yielding described the experience of flying at such heights as surreal, the curvature of the earth visible below, sky fading from blue to black, and the sense that they were balancing between worlds. The Blackbird was not only a spy plane, it was a statement of what human ingenuity could achieve when driven by competition and fear. At those heights, the air was so thin that any mistake meant instant death. Yet the mission demanded absolute calm, as if flying through a vacuum. The pilots wore pressurized suits similar to those used by astronauts, for they were, in every sense, grazing the edge of space. But while planes explored the high boundary of the atmosphere, other experiments pushed the edge even further. Same technology that could lift cameras and pilots could also carry weapons. And by the early 1960s, both nations began testing rockets and missiles that could rise above the atmosphere before falling back toward Earth. The sky became a laboratory of destruction. In 1962, the United States launched Operation Fishbowl, a series of high-altitude nuclear tests conducted in the Pacific Ocean. One of these, called Starfish Prime, took place on July 9th of that year, when a nuclear warhead was detonated 400 kilometers above Johnston Atoll. The explosion was visible across Hawaii, nearly 1,400 kilometers away, lighting the night sky with a green and red aurora unlike anything seen before. The blast created an artificial radiation belt around the Earth, damaging satellites and disabling streetlights thousands of miles away. For the first time, humanity had altered the upper atmosphere through force, leaving behind invisible scars that lingered for years. Scientists later studied the event in disbelief, realizing how little was known about the space just beyond our air. The detonation had released electromagnetic pulses that interfered with radio signals and radar, proving that the boundary above was not just an empty void, was a sensitive, interconnected system that could be disturbed by human actions. Similar tests were conducted by the Soviet Union, each seeking to understand how the atmosphere could be used or weaponized as part of strategic defense. It was a grim era of discovery, when exploration and destruction often traveled side by side. The fear that the sky itself could become a weapon was no longer imaginary. Reports circulated that both nations were studying the possibility of space-based deterrence, satellites armed with nuclear payloads, orbiting silently above the world. Though such plans were never realized, thought alone haunted scientists and politicians alike. The political tension of the time is mirrored by the growing unease among those who studied the upper atmosphere for peaceful reasons. Meteorologists and physicists watched as the sky became a testing ground for weapons and surveillance, its purity compromised by radiation and debris. Yet paradoxically, the same era of rivalry gave birth to some of the greatest advancements in human exploration. The rockets that carried warheads would soon carry astronauts, and the technology designed for reconnaissance would evolve into satellites that mapped the Earth, forecasted weather, and connected people across continents. Out of fear, humanity reached higher than ever before, and in doing so, learned more about the fragile balance that keeps our planet alive. By the late 1960s, treaties began to limit high-altitude and nuclear testing, recognizing the damage that such experiments caused. The Partial Test Ban Treaty of 1963 prohibited nuclear explosions in the atmosphere and outer space, marking the beginning of a global effort to protect the sky from our own ambition. Yet the memory of those years, the silent U-2 flights, the glowing starfish, prime aurora, the blackbird's long arcs across the edge of the stratosphere remains as a testament to what happens when curiosity and fear share the same horizon. The war above the clouds never truly ended. It merely changed its weapons, its purposes, and its forms. But in that uneasy race, humanity learned both the limits of the sky and the danger of turning wonder into strategy. There are places on Earth where the night sky does not rest, where light moves as if alive, and where silence itself seems to glow. The aurora, that trembling veil of green and red and violet, appears most often near the poles, where the invisible breath of the sun collides with the shield of Earth's magnetic field. It is a spectacle older than language, and yet even now, when science has mapped its patterns and measured its origins, it remains one of the few phenomena that feels untouched by explanation. Those who have seen it speak of a stillness unlike any other, of colors that do not simply appear, but seem to think, to flow, to breathe. The lights arrive without warning, twisting like silk in water, vanishing, returning, and vanishing again, leaving behind a darkness that feels deeper for their passing. The story of the aurora begins far from Earth, on the surface of the sun, where storms erupt and send out streams of charged particles known as the solar wind. These particles, mostly electrons and protons, travel across space at speeds exceeding 1,000,000 kilometers per hour, crossing the void between the sun and our planet in about 2 days. When they reach Earth, they are caught by the planet's magnetic field, a vast and unseen structure shaped like an hourglass that extends tens of thousands of kilometers into space. The magnetic field channels the particles toward the poles, guiding them down into the upper atmosphere, where they strike atoms of oxygen and nitrogen between 80 and 500 kilometers above the ground. Each collision releases energy in the form of light, and that light becomes the aurora, natural theater of physics performed in absolute quiet. To scientists, the process is well understood. The green light comes from oxygen, about 100 kilometers above Earth's surface, the red from oxygen higher still, and the blue and purple tones come from nitrogen. The patterns of movement, those graceful arcs and flowing curtains, are shaped by the lines of the magnetic field itself, twist and shift as the solar wind changes. Instruments can measure the electric currents running through the auroras, sometimes strong enough to affect power grids on the ground, yet none of that knowledge captures the experience of seeing it. To watch the aurora is to witness energy made visible, to see the sun touching the sky through color instead of flame. The air at those altitudes is too thin to carry sound, and so the great fires of the heavens move in perfect silence. Long before anyone understood solar winds or magnetic fields, the aurora belonged to story and belief. The people of the far north, the Inuit, said the lights were the spirits of the dead playing ball with the skull of a walrus, their laughter silent only because it came from another world. Others said the aurora was a bridge between the living and the dead, a path the souls of hunters followed toward the next life. To see the lights dance was to know that the ancestors were near, watching the earth below. The Norse imagined the aurora as reflections from the armor of the Valkyries, the warrior maidens who guided the souls of fallen soldiers to Valhalla. When the lights flickered red, it was said to be the glow of their shields as they rode across the northern sky. The Chinese, who recorded sightings as early as the 7th century BCE, believed the lights were celestial dragons breathing fire, their movements a sign of cosmic harmony or warning. To them, the heavens were alive, and the aurora was a pulse in its body. Each of these interpretations, though born from myth, carries an understanding that feels close to truth. The aurora is indeed a crossing, a meeting of worlds. The particles that paint the sky have traveled from the sun, across 93 million miles, only to be caught and transformed into light within the thin edge of Earth's air. What begins as violence on the sun ends as grace above the poles. For those who study it, this transformation is part of the planet's defense. It's a visible side effect of the magnetic field that protects all life below from the harsh radiation of space. The same invisible shield that turns solar storms into color also keeps the atmosphere from being stripped away. Without it, the Earth would be bare and lifeless, more like Mars than the living world we know. In March of 1989, a particularly strong solar storm struck the Earth, triggering auroras so bright they were seen as far south as Cuba and disrupting power grids across Canada. For a single night, the sky above North America shimmered with green fire, and even those who had never heard of the aurora before stood in wonder. The newspapers called it the night the sky caught fire, though in truth, it was the air itself that had become luminous. Satellite images showed ribbons of light encircling the poles, twisting and folding as if the planet were wrapped in moving fabric. Each wave of light corresponded to invisible waves of charged particles flowing down magnetic lines, proof that even the emptiness above us is full of motion. What is most striking about the aurora is not just its beauty, but its quietness. It is a display of unimaginable energy, yet it unfolds without sound or heat. To stand beneath it is to feel both small and connected, aware of how thin the air really is, how fragile the line between Earth and space can be. The ancient myths spoke of spirits and dragons because they sensed that something beyond comprehension was happening in the heavens, a conversation between the sun and the earth, written in light. Even now, when we know the scientific cause, that feeling has not gone away. The aurora remains a reminder that we live within a greater system, one that hums with unseen electricity and whispers of forces that do not need words. On quiet winter nights in northern latitudes, the lights still return, sometimes faint and distant, sometimes fierce enough to color the snow green and red. They flicker, vanish, and reappear, like thoughts passing through the sky. Scientists may call them ionized particles, but to those who watch, They remain living sparks that dance in silence, proof that even in the coldest and darkest parts of the earth, light finds a way to move, to speak, and to remember. There is a light that never entirely leaves the earth, a pale, secret luminescence that fills the upper air, even after the sun has gone and the stars have taken their places. It is not the glow of dawn or the echo of sunset, nor is it the light of the aurora that dances in shimmering waves near the poles. It is something quieter, more constant. A faint radiance known as airglow, invisible sigh of the atmosphere itself. Breathing in the energy of the day and exhaling it gently through the long hours of night. To those who live beneath the sky, it is unseen, lost to the greater brightness of the stars and cities below. But to astronauts orbiting far above, it appears as a delicate band of green and red light hugging the planet's horizon, a kind of living border between the world of air and the sea of darkness beyond. Airglow is born from the faint after effects of sunlight. During the day, ultraviolet rays from the sun strike the molecules of oxygen and nitrogen in the upper atmosphere, separating them into individual atoms. When night falls, those atoms slowly recombine, releasing the stored energy as light. The process is constant, repeating every day in an endless rhythm that scientists call chemiluminescenza, quiet reaction of molecules that keeps the edge of the atmosphere softly illuminated. It happens mostly between 80 and 100 kilometers above the ground, in the same fragile layers of air where meteors burn and auroras shimmer. And though it is far too faint to be seen by the human eye from the ground, sensitive cameras reveal it as a green glow spread thinly across the night sky. Shifting and rippling like breath on glass, astronauts aboard the International Space Station have described it in tones of awe, the way poets once described the sea or the desert. When viewed from orbit, the Earth appears wrapped in a thin halo of color, a glowing thread that outlines its curve. The green band of airglow lies just above the dark limb of the planet, so fine and steady that it looks drawn by hand, like the border of a dream. Photographs taken from the station show this band separating the deep blue of the lower atmosphere from the blackness of space, a line so narrow that it could be mistaken for the edge of a bubble. In those moments when the sun slips below the horizon and the world turns toward night, the air itself seems to light from within. As though the planet were softly remembering the day, scientists studying airglow have found that its color changes with altitude and with the composition of the gases that emit it. The familiar green comes from oxygen atoms releasing energy about 90 kilometers above the surface, while fainter red and blue glows occur higher still, produced by oxygen and sodium atoms at altitudes of up to 200 kilometers. Occasionally, thin sheets of orange or yellow appear, traces of sodium lifted into the upper air by meteors that have disintegrated long before. Each color marks a layer, and together they form a silent tapestry woven by the chemistry of the atmosphere. Unlike auroras, which depend on solar storms and magnetic fields, airglow never stops. It is the Earth's own quiet light, self-sustained and unhurried, more like the hum of a resting machine than the flare of a storm. The first scientific mention of airglow came in the early 20th century, when Swedish physicist Bengt Hedlund began measuring faint spectral emissions from the night sky. Later in the 1950s and 1960s, rockets carrying instruments into the upper atmosphere confirmed that this glow was real and persistent, visible even in the absence of sunlight or magnetic disturbance. When the first astronauts reached orbit in the 1960s, they saw it for themselves, describing it as a green horizon line that seemed to follow the curve of the Earth wherever they looked. To them, it was both scientific and spiritual, a reminder that even the darkness between day and night is alive. There is something deeply human in the idea that the air around our world shines even when no one can see it. The faint green band that circles the planet is proof that Earth is not simply illuminated from above, but from within. It breathes light back into space, just as it breathes out air and warmth and water. The glow never flickers or fades completely. It waits patiently for the next sunrise, when the cycle begins again. This soft rhythm of illumination mirrors the rhythm of life below, the pulse of tides and seasons, and the quiet renewal that turns each night into a preparation for dawn. From the ground, Though hidden to our eyes, airglow still touches us. Sensitive cameras set up in remote deserts and mountain ranges capture it as faint waves of green and red sweeping across the heavens.
Oh.
Mistaken sometimes for northern lights or reflections of distant cities, on those rare, clear nights when pollution and cloud vanish entirely, the human eye can sometimes sense it as a strange brightness to the darkness, a barely visible haze that lingers even after the stars have burned their brightest. To know it is there is to realize how delicately the earth holds its balance, how the boundary between air and space is not emptiness but transition, a slow fading that never truly ends. In its own way, airglow is the earth dreaming. The atoms that compose it have been split apart by sunlight, and now, in the peace of night, they come together again, releasing color instead of sound. No two nights are the same, for the patterns shift with wind and temperature and the subtle tides of the upper atmosphere, unseen currents that move faster than any ocean below. It is a reminder that the sky we live under is never still, that even in what we call darkness, there is movement and light. When astronauts describe looking down from orbit and seeing that thin glowing edge, they often speak of how fragile the Earth appears, how small the layer of air that protects all life truly is. They watch it shimmer in silence and realize that everything oceans, mountains, forests, and cities exists beneath that narrow band of living light. To imagine it is to picture the planet as a breathing organism, wrapped in a soft exhale of green, its pulse steady against the emptiness of space. The glow is constant, though we seldom notice it, just as our own breath continues even when we sleep. In that sense, the airglow is the night made visible, the earth quietly remembering the sun long after it is gone, holding its warmth in the atoms of the sky, waiting for morning to come again. High above the weather, beyond the whisper of air and the shimmer of auroras, there is a realm that looks empty, but is anything but. It circles the planet in silence, invisible to the eye, yet filled with movement, a thin shell of metal, circuitry, and memory that humanity has built without ever truly seeing it. These are the invisible highways of orbit, the paths that satellites follow endlessly around the Earth, forming an unseen architecture that has changed the modern world in ways few could have imagined when the first of them rose into the sky. It is a place of precision and fragility, where each object must travel at extraordinary speed just to stay aloft, and where a single collision can send fragments racing through space like bullets. To look up at night is to see only darkness, but hidden beyond that darkness is the quiet traffic of our age, the steady hum of machines that never sleep. The story began in October 1957, when a silvery sphere the size of a beach ball was launched from the Kazakh steppe atop a modified R-7 rocket. It was called Sputnik 1. And though it was small and simple, just a polished metal body with 4 thin antennae, it marked the beginning of the space age. Its signal, a repeating radio beep, could be heard by amateur operators across the world, a mechanical heartbeat announcing that something human was now circling above. It completed one orbit every 96 minutes, passing over every continent, visible sometimes as a bright moving point of light in the night sky. That simple satellite, weighing less than 90 kilograms, carried no camera, no instrument, only the message that Earth was no longer alone. Within months, both the United States and the Soviet Union began launching their own satellites, and the sky that had once belonged solely to weather, birds, and meteors became the first layer of a new frontier. In the decades that followed, those orbits filled quickly. Communication satellites, weather satellites, navigation systems, scientific observatories, and defense platforms joined the steady flow. The first human voices to cross continents in real time, the first images of hurricanes from above, the first maps of the ozone layer all came from these silent machines tracing invisible rings around the world. By the 1970s, there were hundreds. By the turn of the millennium, thousands. Today, there are more than 8,000 functioning satellites and tens of thousands of fragment-spent boosters, broken panels, and shattered debris, all moving at speeds exceeding 27,000 kilometers per hour. Each follows a precise path, balanced between Earth's gravity and the outward momentum of motion, locked in orbits that can last decades or even centuries. Together, they form a delicate lattice, a web of human presence surrounding the planet. From the surface, it is impossible to see this network, yet it touches nearly every aspect of daily life. GPS signals guide aircraft, ships, and smartphones. Communication satellites link continents. Weather satellites warn of storms before they form, and observation platforms measure everything from forest fires to sea temperature. Each of these functions depends on an orbit carefully calculated to within fractions of a second. Low Earth orbit, stretching up to about 2,000 kilometers, is the busiest layer, filled with satellites that pass overhead in mere minutes. Above it lies medium Earth orbit, home to navigation networks like the American GPS and the European Galileo systems, circling every 12 hours. Farther still is geostationary orbit, 36,000 kilometers above the equator, where satellites move at the same speed as the planet's rotation and appear motionless in the sky. Two engineers. These zones are highways, paths of stability in the thin edge between air and space. But two astronomers, looking from the ground, they are reminders that the sky is no longer empty. The beauty and danger of these highways lie in their precision. Every object in orbit moves with such speed that even a small piece of debris, a screw, paint chip, a shard no larger than a coin can, cause catastrophic damage on impact. In 2009, a defunct Russian satellite collided with an active American one, Iridium-33, producing a cloud of more than 2,000 fragments that continue to orbit today, each one capable of tearing through metal. Scientists call this growing field of debris the Kessler syndrome, after NASA researcher Donald Kessler, who in 1978 warned that an unchecked increase in collisions could trigger a chain reaction, filling orbit with so much debris that future launches would become impossible. It is a sobering thought that humanity, in its eagerness to reach the heavens, could one day block its own path. Astronauts aboard the International Space Station have seen these dangers firsthand. The station, which orbits at about 400 kilometers, occasionally performs small maneuvers called debris avoidance burns, shifting its position by a few meters per second to dodge fragments detected by radar on the ground. Most of the time, these fragments pass unnoticed, but sometimes they come close enough to rattle the crew awake. A reminder that even in space, traffic must be managed. The station's windows often frame a sight both humbling and haunting, the earth below glowing softly with airglow, the blackness above filled with unseen movement, and the faint, silent shimmer of human-made stars tracing their endless loops. As the number of satellites grows, so too does the question of what it means to fill the heavens with our machines. Companies and nations now plan to launch constellations of thousands more, promising global internet access, navigation coverage, and real-time observation of every corner of the planet. Yet each launch adds new material to the orbital environment, new paths to monitor, new risks to manage. Some astronomers have already begun to notice the effects. Long-exposure photographs show bright lines where satellites pass through the field of view, their reflections streaking across the images of distant galaxies. The sky that once told stories of gods and heroes now tells the story of ourselves, of a civilization that has stretched its reach so far that even the night is marked by its hand. There is no denying the achievement. These invisible highways have allowed humanity to see itself from above, to map its own reflection on a global scale, to predict, to connect, and to understand the planet as one whole. Yet they have also created a new kind of presence, one that is neither on Earth nor entirely in space. A man-made halo that grows brighter and more crowded each year. When the first Sputnik circled the Earth, it did so alone, a single glint against an untouched sky. Now, the heavens are filled with thousands of echoes of that same light, a silent procession of purpose and debris, order and chaos. Somewhere within that vast mechanical constellation lies the question of how far humanity can extend itself before it begins to lose sight of the fragile world these orbits were meant to serve. In the winter of 1958, when the world was still young in its exploration of space, A small American satellite named Explorer-1 rose above the atmosphere and began to send back signals that would change the way humanity understood the invisible forces surrounding the Earth. It was built under the direction of physicist James Van Allen from the University of Iowa, whose instruments aboard the spacecraft were designed to measure cosmic rays, the high-energy particles that stream through the universe. What those instruments detected, however, was not the expected faint background of distant radiation, but intense bursts of charged particles that overwhelmed the detectors each time the satellite passed through certain regions of its orbit. Within months, further measurements from Explorer-3 confirmed the discovery. The Earth was encircled by vast belts of trapped radiation, unseen but powerful, forming protective and perilous rings that came to be known as the Van Allen belts. These belts, though invisible, are immense in scale. They extend from roughly 1,000 kilometers above the surface to more than 60,000 kilometers into space, wrapping around the planet like luminous bands of energy held in place by the Earth's magnetic field. In simple terms, they are reservoirs of charged particles, mostly protons and electrons, that originate from the solar wind and from cosmic rays entering Earth's magnetosphere. The magnetic field acts as a kind of trap, guiding these particles along curved paths that circle the planet endlessly, oscillating between the poles and bouncing back and forth like beads on a string of magnetism. To the human eye, they are not visible. Yet if one could see them, the Earth would appear as a glowing orb surrounded by two immense toroidal rings of shimmering radiation, forever shifting and breathing with the pulse of the sun. The inner belt, discovered first, lies closest to Earth and is dominated by energetic protons, created when cosmic rays collide with atoms in the upper atmosphere. These protons can remain trapped for years, forming a dense region of radiation that begins around 1,000 kilometers above the equator. Farther out lies the outer belt, filled mainly with electrons from the solar wind, which are more variable and change dramatically with solar storms. Together, these belts serve as both shield and hazard. They protect the surface of the Earth by deflecting much of the solar radiation that would otherwise strip away the atmosphere and harm living organisms. Yet they also pose a constant danger to satellites and spacecraft that pass through them, where radiation levels can rise thousands of times higher than what exists at sea level in the early years of space exploration. The Van Allen belts were an unknown obstacle that nearly ended some of humanity's first ventures beyond the atmosphere. When the first American astronauts were being trained for Project Mercury in the early 1960s, engineers and scientists debated whether the radiation levels would be safe for human passage. Calculations showed that short trips through the belts, lasting only minutes, would expose astronauts to manageable doses, but longer missions could prove deadly. The first uncrewed tests of the Explorer and Pioneer programs revealed how severe the radiation could be. Instruments failed, solar cells degraded, and onboard electronics short-circuited without warning. Even the first Soviet missions, such as Luna 1 and 2, encountered difficulties that engineers later traced to radiation interference. In those days, space was still thought of as an empty void, but Van Allen's discovery revealed that it was, in fact, a dynamic environment filled with unseen energy, capable of both sustaining and destroying. Perhaps no mission demonstrated the dual nature of these belts more dramatically than the early Apollo tests that prepared for human travel to the moon. In 1968, Apollo 7 became the first crewed mission to pass through the lower edge of the radiation zones, followed by Apollo 8, which traveled beyond them entirely on its historic journey around the moon. The astronauts experienced no harm thanks to the short transit time and the protective shielding of their spacecraft. But the data they carried back confirmed that these invisible rings were not just a scientific curiosity, they were a constant, living reminder of how complex and dangerous near-Earth space could be. Every subsequent mission had to account for them, plotting trajectories and timing launches to minimize exposure. What makes the Van Allen belts extraordinary is how they move and change in response to the sun. During periods of high solar activity, when flares and coronal mass ejections send floods of charged particles toward Earth, the belts can expand outward, doubling in size, and their radiation levels can spike within hours. Sometimes, a third temporary belt forms, appearing between the main two and lasting for days or weeks before dispersing. These fluctuations are part of what scientists now call space weather, an ever-changing interaction between the solar wind and the planet's magnetic field. The same storms that create beautiful auroras at the poles also stir the radiation belts into motion, releasing bursts of energy that can disable satellites and disrupt communication systems around the world. By the late 20th century, scientists had learned to map these regions with increasing accuracy. The NASA missions of the 1990s and early 2000s, such as the polar and cluster satellites, measured how particles move within the belts, while in 2012, the Van Allen probes were launched specifically to study their structure. Those twin spacecraft revealed details that even Van Allen himself could not have imagined. How electrons within the belts are accelerated to near light speed. How waves of electromagnetic energy ripple through the magnetosphere like ocean currents. And how the radiation belts continually rebuild themselves after being disrupted by solar storms. They confirm that the belts are not fixed structures, but living systems, shifting and reforming in response to forces far beyond human control. And yet, for all their complexity, the Van Allen belts remain one of Earth's greatest protectors. Without them, the constant stream of charged particles from the sun would strike the upper atmosphere directly, eroding it away over millions of years and exposing the surface to deadly radiation. It is no exaggeration to say that life on Earth owes its existence in part to these unseen rings of fire that guard the planet like a magnetic halo. They are both barrier and reminder, a sign that even at the boundary between Earth and space, the planet continues to shield what it has nurtured for so long. When astronauts in orbit look down and see the faint green glow of air glow or the shifting bands of aurora, they are seeing the outer signs of a defense system that is always at work, invisible yet unyielding. Shaped by the same forces that once filled James Van Allen's instruments with noise and changed the course of space exploration forever. High above the surface of the Earth, beyond the shimmer of air and the reach of clouds, there is a constant hum that never stops, a thin, steady chorus of signals moving across the void, circling the planet like invisible threads of thought. It began the moment we learned to send our voices into the air, first as sparks of electricity along wires, then as waves that could travel freely without them. What started as a whisper between 2 points on Earth has now become a vast web of transmissions, each one bouncing between satellites, drifting outward into space, and returning again like echoes that never quite fade. The edge of space, once silent, now hums with the sound of human presence, a delicate and ceaseless vibration that tells the universe that we are here. The first radio waves strong enough to leave Earth were born in the closing years of the 19th century, when inventors like Guglielmo Marconi and Nikola Tesla experimented with transmitting signals across long distances. By December 1901, Marconi had managed to send the Morse code letter S across the Atlantic Ocean from Cornwall, England, to Newfoundland, Canada, proving that the curvature of the planet and the openness of the sky could be bridged by invisible energy. What neither he nor anyone else realized at the time was that some of those same waves were not confined to Earth. A fraction escaped upward, spreading outward forever at the speed of light. Even now, that simple signal, if unbroken, would be nearly 125 light-years from here, still expanding into the dark, carrying the faint record of a human experiment to the stars. As radio grew, so did the web of signals surrounding the planet. By the 1930s, with the rise of broadcast radio, the sky above Earth had begun to fill with overlapping transmissions, music, voices, news, all traveling outward in a growing sphere of sound. During World War II, radar systems added their own pulses, sending short, rhythmic bursts into the air that reflected off planes, ships, and even the upper atmosphere itself. In the 1950s and 60s, when satellites like Telstar, Echo 1, and Relay 1 were launched, the nature of that hum changed forever. Communication was no longer limited to line of sight or atmospheric reflection. It now had mirrors orbiting above. The Echo 1 satellite, launched in 1960, was a giant balloon coated in aluminum, a passive reflector that allowed radio signals to bounce across oceans. When engineers sent a signal from California and heard it return from the East Coast a fraction of a second later, it was like hearing their own voices come back from space. The sky had become both messenger and mirror. These invisible pathways of sound and data multiplied quickly. Every satellite added its own layer to the network, relaying phone calls, television broadcasts, and telemetry between continents. The Earth, once a quiet planet, had become a transmitter. Its atmosphere and orbits filled with coded pulses that reached farther each year. To an observer from another world, our planet would appear as a faintly glowing sphere of radio noise. Surrounded by a shell of signals, some structured, some chaotic, spreading outward in every direction. The first major broadcasts strong enough to escape the ionosphere. Permanently were the television signals of the late 1930s and 40s, episodes of early programs, speeches, music, and even Olympic Games are now more than 80 light-years away. Traveling past the nearest stars, each one is a frozen echo of a moment on Earth, sent not deliberately but as a byproduct of communication. A digital pollen carried by radio light, it is no surprise. Then, that as our signals left the Earth, we began to wonder if others might be coming toward us. In the 1960s and 70s, the search for extraterrestrial intelligence emerged as a scientific attempt to listen for organized signals from the cosmos, something that might reveal that another civilization was also reaching out. Large radio telescopes like those at Green Bank in West Virginia and Arecibo in Puerto Rico scanned the skies, sweeping the frequencies most likely to carry artificial transmissions. For years they found nothing but natural noise pulsars, quasars, the hiss of cosmic background radiation until one night in August 1977, when something extraordinary happened. Astronomer Jerry Emin, working with the Big Ear radio telescope in Ohio, detected a narrowband radio signal that lasted 72 seconds, coming from the direction of the constellation Sagittarius. It was strong, precise, and unlike anything known to come from Earth or any natural source. On the computer printout, Emin circled the burst of data and wrote one word in the margin: wow. That signal, later called the WOW signal, has never been detected again. It did not repeat, and no one could find a clear explanation for it. Some said it was a reflection from a passing satellite. Others, that it was a natural burst of cosmic radiation.
Ow.
But none of the theories ever satisfied everyone. What remains is the mystery of that brief transmission of sound that seemed to come from nowhere, reaching us across the same invisible highways we built for ourselves. It was as if the universe had, for a moment, spoken back. Whether it was an accident or an answer, it joined the great collection of signals moving endlessly between stars, adding one more echo to the noise that surrounds our planet. Today that noise has become almost infinite. Every phone call, internet connection, television broadcast, and satellite ping contributes to the vast electromagnetic ocean that surrounds Earth. GPS satellites send continuous streams of data. Whether satellites beam images down to stations below, and deep space probes like Voyager 1, now more than 23 billion kilometers away, still send faint signals home across the void. The edge of space hums with our presence, though we rarely hear it. To the astronauts orbiting above, it is a quiet world, but their instruments know the truth. They move through a realm filled with invisible whispers, the sound of humanity reflected and refracted through the upper atmosphere. Passing endlessly between the ground and the stars, the edge of space is both boundary and mere place where what we send out returns. Changed and delayed, but still our own. The first radar pings that left Earth in the 1940s are now more than 80 light-years away, their faint echoes moving outward through the interstellar dark. Somewhere beyond them, the WOW signal still drifts through the galaxy, fading slowly, but never gone. Each of these transmissions is a trace of our time here, a record of our voices calling across a vast silence. The space around our planet is no longer empty. It is alive with conversation, filled with songs, words, and data, all circling and echoing back like memories that refuse to disappear. And perhaps somewhere beyond the reach of our instruments, those same echoes will one day find an answer, proving that in sending our voices into the dark we were never truly speaking alone. There is a place above the Earth where air and space meet, a region that belongs to neither, where the last molecules of atmosphere drift apart and vanish into an ocean of emptiness so vast that it seems to swallow all motion and sound. This is the true boundary of the world, the cold black sea that begins just beyond the reach of weather, where gravity still holds but weakly, and where the familiar warmth of sunlight turns thin and sharp, cutting through the void without air to soften it. Here, the blue fades completely, replaced by a darkness that exists even in daylight. And the silence is so complete that it feels like pressure itself, an invisible weight pressing on the hulls of ships, the glass of helmets, the skin of metal that dares to cross it. For those who have traveled there, this region is less a place than an experience. The moment when everything human falls away and only the vast, indifferent universe remains. The transition from atmosphere to vacuum is not abrupt. For nature rarely draws its lines clearly. The air grows thinner in stages until the idea of air itself ceases to apply. At around 100 kilometers, the Kármán line. Airplanes can no longer lift themselves, but even at 400 kilometers, where the International Space Station orbits, there are still traces of gas so faint that a single molecule might drift for kilometers before meeting another. This is not the absence of air, but its ghost, the last exhalation of Earth stretching outward into nothing. Within this thin veil, spacecraft move through a strange half-state, not fully beyond gravity, but no longer within the comforting pull of atmosphere. The result is microgravity, a condition where everything seems to float. Not because gravity has disappeared, but because the objects are all falling together at the same speed. Locked in perpetual descent around the planet, inside such an environment, even the smallest actions take on new meaning. A drop of water becomes a wandering sphere. A strand of hair floats like a thread in windless air. And a gesture of the hand can send a person drifting silently across the cabin. From the outside, this region appears still. But in truth, it is filled with motion particles of energy, bursts of radiation. In streams of atomic debris hurled from the sun and the cosmos beyond, without the protection of the thick lower atmosphere, spacecraft must endure constant bombardment by cosmic rays. High-energy particles that move at nearly the speed of light. These rays, born from distant supernova and violent magnetic storms, strike the hulls of orbiting craft with invisible force, sometimes passing through the walls entirely. They are a reminder that space is not merely emptiness, but a sea of radiation, unseen and deadly. To shield against them requires layers of aluminum, carbon composites, and sometimes even water, which absorbs the energy more effectively than metal. Astronauts who spend months in orbit speak of seeing flashes of light even when their eyes are closed. Tiny sparks that occur when cosmic rays strike the retinas directly. A private aurora born inside the human body, temperature too, becomes an unfamiliar thing here. Without air to carry heat, warmth and cold exist side by side, separated only by shadow. A piece of metal facing the sun can rise above 200 degrees Celsius, while the opposite side, hidden from light, can plunge below -150. The surfaces of spacecraft must endure these extremes continuously as they orbit the Earth every 90 minutes, passing from bright day to deep night 16 times a day. As they move into darkness, a faint frost often blooms on the metal, a delicate film that forms as the heat radiates away into the void. In the sunlight, that frost disappears instantly, vaporized by radiation so intense that paint flakes and plastic weathers into dust. Engineers design every bolt, every plate, every wire to survive this cycle of burning and freezing, yet even with the best materials, the wear is relentless. The cold black sea does not forgive. It only accepts. Inside the small cabins that cross this frontier, silence takes on a texture of its own. Without air, there is no sound from outside, no wind, no hum, no echo. The only noises come from within, the hiss of oxygen through vents, the soft click of instruments, the steady rhythm of breathing through a suit. Outside, even motion itself makes no sound. When an astronaut touches the glass of a window and looks outward, the earth below turns silently, the continents outlined by city lights, the oceans black and immense. Beyond that curve, the stars burn with steady light, unshaken by air or flicker. each one fixed and sharp as if carved into the sky. The boundary between the window and the void feels impossibly thin. Just millimeters of glass separating human life from absolute silence. It is in this stillness that many who have gone there speak of a strange paradox. They feel weightless, yet also burdened, surrounded by nothing, yet conscious of everything. The absence of air becomes a kind of mirror, reflecting thought back upon itself. The blackness outside is not empty, it is filled with time, with distance, with the quiet memory of everything that has ever existed. Light from distant stars that died millions of years ago still passes through this space, mingling with the radiation of newborn suns, the echo of old explosions, with the invisible breath of galaxies. The human eye cannot see these layers, but the mind feels them, as if the void were listening. The first astronauts to experience it, men like Yuri Gagarin in 1961. Or John Glenn the following year, spoke of it with a reverence that bordered on disbelief. They described the Earth as fragile, a glowing sphere wrapped in a thin blue halo, surrounded by endless dark. They also spoke of the silence, how it seemed to stretch beyond sound, beyond time. To look out from that place is to see the world as both sanctuary and island, alive and small against the infinite. The cold black sea is the truest form of isolation, yet within it lies connection, for everything on Earth. Every breath and heartbeat depends on the barrier that separates this thin layer of warmth from the deep and deadly quiet beyond. When sunlight strikes the edges of spacecraft or helmets at that altitude, it gleams like water, scattering faint rainbows across the glass. But the light carries no heat, no comfort. It is pure energy, stripped of its softness, older than humanity itself. It moves through the blackness as it always has, crossing the boundary between worlds, touching metal, skin, and glass, then continuing outward. In that moment, the line between atmosphere and vacuum dissolves entirely, and the Earth becomes what it has always been, a small, glowing island floating on a cold black sea that has no shore, no sound, and no end. There comes a moment in the history of every boundary when someone must step beyond it, not with certainty, but with trust in the strength of their own breath and the thin walls of the machines that carry them. For the boundary between Earth and space, that moment came on March 18, 1965, when a Soviet cosmonaut named Alexei Leonov opened the hatch of his spacecraft, Voskod 2, and became the first human being to step into the open void. Until that day, spaceflight had been a sealed experience, a journey conducted through windows and radios, the traveler enclosed and protected. Leonov's mission changed that forever. When he left the safety of the capsule, tethered by a single line, he crossed from being a passenger of space to being a presence within it, a lone figure suspended between the curved blue planet below and the endless black above. For 12 minutes, he floated in the silent expanse where no human had ever stood. And in those minutes, the meaning of exploration itself changed. The conditions were unforgiving. Leonov's spacesuit, built for survival rather than comfort, was a prototype of what engineers called a Burkat suit, inflated with pure oxygen and reinforced with layers of rubber and aluminum. As soon as he entered vacuum, the suit expanded under the internal pressure, stiffening until his arms and legs could barely bend. The gauge on his wrist told him that his oxygen levels were rising dangerously, and he realized that the suit's joints had ballooned so much that he could no longer fit through the hatch. His body was swelling against the limits of the material. For several minutes he hovered in a state between triumph and death, watching the Earth move beneath him as he struggled to find a way back inside. There was no sound, only the faint buzz of his breathing and the hiss of air in his helmet. In that moment, he was the loneliest human who had ever lived. To save himself, Leonov made a decision that broke every safety rule written for the mission. He opened a small valve and began bleeding oxygen out of the suit, reducing the pressure until it softened just enough for him to bend his arms again. It was a desperate gamble, to much loss of air, and he would suffocate, too little, and he would remain trapped. But it worked. Slowly, clumsily, he pulled himself back, toward the hatch, head first at first, and realizing he could not fit that way, twisting until he could slide through feet first into the narrow airlock. When he finally sealed the door and repressurized the chamber, his body was drenched in sweat, the temperature inside the suit near 40 degrees Celsius. He had been in open space for just over 12 minutes, yet those 12 minutes redefined what humanity was capable of. Later, he would say that when he looked down at Earth, he saw not a planet but a miracle, living sphere floating in nothing, fragile and beautiful beyond comprehension. After Lenov's spacewalk, others followed, each one learning that to step outside the capsule was to confront both the limits of technology and the depths of human emotion. For months after Lenov's feat, NASA began testing its own extravehicular activities, or EVAs, with astronaut Ed White during the Gemini. For mission, in June 1965, White's spacewalk was shorter and smoother, lasting just over 20 minutes, and he described it afterward as the most profound experience of his life. He moved using a small handheld propulsion gun, gliding around the capsule in complete silence, tethered only by a cord and the faith that it would hold. As he floated above the clouds, the sunlight turned his visor gold, and he radioed to mission control that he wished he could stay outside forever. It took repeated commands from his crewmate, James McDivitt, to convince him to return. When he finally did, he said he felt reluctant to re-enter, as if the boundary between space and home had suddenly become a line he did not want to cross again. The danger, so never left. In the early years of extravehicular activity, even the smallest mistake could mean death. In 1971, the Soyuz 11 mission ended in tragedy when a cabin depressurization killed its three-man crew upon re-entry, reminding the world how thin the line between life and vacuum truly was. For every graceful image of a spacewalker drifting above Earth, there were countless hours of planning, fear, and calculation that preceded it. The suits became more advanced, more flexible, equipped with self-contained life support systems, radios, and heaters. Yet the essential act remained the same. A person leaving behind the last layer of safety to enter a place where no sound travels and where every breath must be manufactured by machine by the time of the Apollo missions. The spacewalk had become not just an act of survival or test of courage, but an extension of human curiosity. In July 1969, when Neil Armstrong and Buzz Aldrin stepped onto the lunar surface, they were performing a kind of spacewalk on a different scale, walking not above the Earth, but on another world entirely. The sensation, as Armstrong later described it, was one of weight and distance collapsing together, the Earth rising in the black sky above the moon's horizon, silent and remote, like a memory of home. The experience of walking in space, whether in orbit or on another body, carries the same paradox. The farther one moves from the Earth, the more powerful its pull becomes, not physically, but emotionally. Modern astronauts continue this ritual, each spacewalk a renewal of that first crossing by Leonov. On the International Space Station, where the thin shell of atmosphere gives way to the vacuum beyond, crews perform maintenance and repairs, floating outside for hours at a time, surrounded by a silence so complete that even the movement of their tools seems impossibly loud within their helmets. When the sunlight hits the station, everything gleams: handrails, panels, cables, and when it passes into shadow, frost forms instantly on the metal, sparkling against the blackness. The Earth moves below them at 8 kilometers per second, its continents sliding by like living maps. The auroras flashing at the poles, the oceans turning silver in moonlight. The astronauts who work there often describe a feeling that is neither fear nor joy, but something quieter, a sense of witnessing eternity from just beyond its. Lenov himself never forgot what he saw on that first spacewalk. In later years, he painted the view from memory, the curve of the planet, the deep black of space, the small figure of a man floating between the two. He said that when he was outside, looking at Earth through his visor, he felt both infinite and fragile, as though he were the only living soul in the universe. That feeling, shared by every person who has crossed the line between air and vacuum, remains the essence of spacewalking. To be an edgewalker is to exist for a moment, between the safety of home and the infinity of the unknown, to feel the pull of gravity below, the vast silence above, and to realize that in the great balance between the two lies the story of every human being who has ever dared to look up, far above the blue curve of the Earth, where the air has long since vanished and the light falls unbroken by clouds. There drifts a strange and silent collection of objects, a man-made constellation that no one can see from the ground, yet one that now circles the planet like a quiet memorial to every step humanity has taken beyond its atmosphere. It is made not of stars or dust, but of the fragments of our own ambition. Abandoned satellites, lost tools, empty rocket shells, fragments of paint, shattered solar panels, and forgotten bolts spinning endlessly through the dark. Each piece has a story, and each one, in its own way, is a footprint left behind in a place where no wind or rain will ever wash it away. The sky has become our new museum, a gallery of relics that never sleep. Orbiting in twilight long after their purpose has been forgotten, it began, so many human stories do, with invention and hope. When the first satellites rose into orbit in the late 1950s, they carried the optimism of an age that believed technology would lift the world out of its struggles. Sputnik 1, launched by the Soviet Union in October 1957, stayed in orbit for just over 3 months before burning up upon re-entry. But the fragments of its booster stage remained aloft for years. After that, each new launch added something else, a stage that failed to deorbit, a casing that broke apart, a discarded antenna. For a while, the debris was so sparse that no one thought much of it. The emptiness of space seemed infinite, and a few bits of metal circling high above appeared harmless. But as decades passed, the orbits began to fill. And now, the region just beyond our atmosphere is crowded with more than 100 million fragments. From entire satellites down to flecks of paint moving at speeds faster than bullets. The emptiness we once dreamed of conquering has become a graveyard of our own creation. Some of those fragments tell stories of triumph, others of loss. In 1965, during the Gemini 4 mission, astronaut Ed White became the first American to walk in space. As he floated outside his capsule, a small tool slipped from his hand and drifted away. Becoming one of the first pieces of human debris to orbit the Earth, it was a harmless beginning, yet symbolic of something larger, the realization that, even in the vacuum of space, we leave traces of ourselves behind. Later missions lost cameras, gloves, wrenches, and even a wrench case, each one spinning away until gravity's slow pull eventually consumed them in flame. But not all have fallen. Some remain circling still, relics of moments when the human hand reached beyond its limits and left a small, silent echo of its effort. Other relics are less innocent. In 2007, a Chinese missile test destroyed an aging weather satellite, shattering it into more than 3,000 tracked fragments and tens of thousands of smaller ones, all spreading into new orbits that will remain for decades. 2 years later, in 2009, an inactive Russian satellite collided with an operational American one, Iridium-33, creating another cloud of debris that continues to expand. Each fragment, even those smaller than a pebble, moves at nearly 8 kilometers per second, fast enough to pierce metal, rupture tanks, or shatter solar panels. To the human eye, these fragments are invisible. But to the radar systems that track them, the sky above Earth resembles a swarm of tiny ghosts, a field of forgotten machinery drifting through perpetual twilight. What began as exploration has quietly turned into accumulation. And the result is a kind of orbiting archaeology of the modern age. The most haunting part of this silent wreckage is its persistence. Unlike the seas or deserts of Earth, where wind and weather erase the marks of time, space offers no cleansing. A wrench lost from a capsule in 1966 may still be circling the planet today, unchanged, frozen in the same slow dance it began decades ago. Even the spacecraft that once symbolized human achievement have become derelict monuments. Vanguard 1, launched in 1958, still circles the Earth after more than 60 years, long dead but unfallen. Its signal silenced in 1964, yet its orbit stable enough to last for another century. It is now the oldest human-made object still in space, a ghost of the early space age that continues to trace its path through the dark. Unseen except by the telescopes that occasionally glimpse its faint reflection, astronauts aboard the International space stations sometimes report seeing flashes of light outside the window's tiny, brief sparks caused by sunlight glinting off distant debris. Each glint is a reminder of how crowded the heavens have become. How the space once thought infinite now carries the mark of human presence. To work outside the station, they must rely on constant tracking data from Earth, maneuvering the station itself when a dangerous fragment passes too close. These avoidance burns, as they are called, are small adjustments. But they reveal a deeper truth, that our progress has left behind a trail we can no longer fully control. The more we explore, the more we scatter, and the cleaner the technologies become. The more fragile the balance above our heads grows. In a way, these fragments have become our legacy, unwanted, yet enduring. They orbit silently through sunlit arcs and long nights, tracing patterns of history invisible to the naked eye. Each one speaks of a moment when humans reached outward, when rockets thundered from the ground and the air trembled with the sound of ambition. But now, decades later, those echoes linger as objects without purpose, drifting endlessly in the dark. They are like forgotten ships left adrift after the explorers have gone home. Their sails frozen and their decks empty, still circling the world that made them. Perhaps one day we will find a way to clear the sky, to collect the fragments and bring them down safely. But for now, they remain where they are, beyond reach and beyond sound. They remind us of our nature, our tendency to leave traces wherever we go, even in places where wind cannot blow and tides cannot wash them away. If someone were to stand on a distant moon and look toward Earth, they would not see the blue planet as it appears in photographs, but as it truly is, surrounded by a faint, invisible halo of human memory, each particle a fragment of intention, each orbit a reminder that exploration is never clean. The forgotten footprints of our journey circle endlessly, reflecting the sunlight as they pass, shining for a moment, and then vanishing into shadow. Just as every dream we've sent into the sky eventually does, high above the storms. In that thin and trembling layer where the atmosphere begins to give way to space, there are lights that appear without warning, flashes of color, so brief and delicate that, for most of human history, no one knew they existed. They last less than a second, glowing like silent fire in the upper air before vanishing into the darkness, leaving no trace except for the astonishment of those few who have seen them. These are the transient, luminous event sprites, elves, and blue jets, strange and fleeting cousins of lightning that dance above thunderstorms instead of below them, inhabiting a region where science meets myth and where the sky seems to reveal, for just a moment, that it still has secrets left to keep. For centuries, people who lived on high mountains or who flew in early aircraft told stories of flashes that appeared above storms, of pale red glows or blue flames rising instead of falling. But these accounts were dismissed as imagination or illusion. Lightning, it was said, always moved downward or outward, never up. Yet the world had always been full of mysteries that only waited for the right eye to notice. It was not until the summer of 1989 that proof finally came, when scientists from the University of Minnesota, testing a low-light television camera, accidentally captured something extraordinary. As they recorded a distant thunderstorm over Oklahoma, 2 faint red columns of light appeared above the clouds, branching like the roots of an upside-down tree. The discovery was accidental, a few frames of film showing something no one had expected to find, but it changed the understanding of the atmosphere forever. These lights were soon named sprites, an old word for mischievous spirits, and the name fit perfectly, for they seemed to appear only when no one was looking, flashing into being at the very edge of vision. Sprites are vast, but fragile, towering columns of red and orange light that rise from the tops of thunderstorms, sometimes reaching as high as 90 kilometers into the atmosphere. They are caused by powerful positive lightning strikes that transfer immense amounts of energy upward, creating brief electrical discharges in the thin air above the storm. From the ground, they cannot be seen without special cameras, but from the vantage point of aircraft and orbiting spacecraft, they are unmistakable, ghostly. Branching structures that seem to hang between heaven and earth for the blink of an eye. Astronauts aboard the International Space Station have described watching them from above, their faint glows spreading across the horizon like the reflection of distant fires. Soon after, sprites were confirmed. Other mysterious forms followed. Pilots began reporting strange blue cones of light shooting upward from the tops of storms, lasting less than a second, reaching altitudes of 40 or 50 kilometers. These were named blue jets, and unlike sprites, which spread outward in soft branching shapes, the jets were narrow and direct, thrusting into the upper air like the flame of a torch. They were so fast that even cameras struggled to record them. And for years, scientists debated whether they were real or simply visual tricks caused by the reflections of lightning below. But in 1994, during a dedicated observation flight over the Pacific, researchers captured clear video of a blue jet emerging from a storm, rising in a perfect line before fading into blackness. The proof was undeniable. The sky was doing something far more complex than anyone had imagined. Then, as technology improved, new forms were seen. ELVs, short for emissions of light, and very low-frequency perturbations due to electromagnetic pulse sources, appeared as enormous disks of light expanding outward in the upper atmosphere. Glowing red or pink and fading in less than a millisecond, they formed at altitudes of around 100 kilometers, higher than sprites or jets, and were triggered by the electromagnetic pulses of powerful lightning strikes. Unlike traditional lightning, which follows a visible path, ELVs spread sideways in thin, expanding circles, sometimes spanning hundreds of kilometers across the sky, in less than the time it takes to blink. They are too faint to see with the human eye and can only be captured by sensitive instruments or by cameras, aboard satellites looking down at storms from orbit. For those who have seen the footage, they look like something out of mytha, a ripple of light, like a halo, blooming and vanishing before reason can catch it. In recent years, high-altitude cameras and astronauts have added more names to this celestial family: blue starters, gigantic jets, trolls, and pixies, each one a different variation of light and energy, shaped by the forces within storms and the thinness of the air above. The terminology often sounds whimsical, as if scientists themselves recognize that these phenomena hover somewhere between science and legend, between data and wonder. To watch them is to witness electricity behaving like poetry-charged air, becoming light, light becoming movement, and movement becoming silence again. For the astronauts who orbit the Earth every 90 minutes, the storms below are not just weather systems, but living things. From their windows, they can see lightning as a constant heartbeat pulsing across the planet's night side. Within those flashes, they sometimes glimpse the strange lights above the storm's red tendrils. Blue cones, rings expanding outward like ripples on dark water. The events happen in silence, for there is no air to carry sound that high, and the only evidence of their existence is the light itself. Those who witness them often speak of how sudden they seem, how they appear and vanish without warning, as if the atmosphere were breathing in secret, rhythms that no one had noticed before. What is remarkable is not just the beauty of these lights, but what they reveal about the world we thought we knew. For generations, humanity believed that lightning was confined to the realm of clouds and rain, that the storms belonged to Earth while the space above remained untouched. Yet these transient events prove otherwise. The atmosphere is not divided but connected. It's an unbroken bridge between the ground and the edge of space, where energy moves freely in both directions. The sprites and elves are the punctuation marks of that connection. Moments when invisible forces briefly become visible, reminding us that even the air is alive with unseen motion. For some, these lights evoke something older than science. The Inuit once spoke of spirits playing above the clouds, and sailors told of St. Elmo's fire, the mysterious glow that crowned ship masts during tempests, thought to be a sign of protection or warning. Perhaps those old tales were not so wrong after all. The border between science and myth has always been thin, and sometimes, when the upper atmosphere lights up in silent fire, the two seem to merge completely. In those moments, the Earth itself becomes the storyteller, whispering through light what words cannot hold, a reminder that even after centuries of discovery, the sky remains unfinished, still writing itself one spark at a time. There are storms that do not roar, that do not churn the sea or tear across the land, storms that make no sound at all, yet reach across millions of kilometers, touching worlds without wind or rain. These are the storms born from the sun itself, eruptions of plasma and magnetic energy that travel outward through space. Silent but immense, brushing against the invisible shield that surrounds the Earth and setting it trembling. To those who watch from observatories, or from the quiet vantage of orbit, these events are both terrifying and beautiful, waves of charged particles sweeping through the blackness, unseen by the eye but capable of lighting the polar skies with auroras and plunging entire cities into darkness. They are called geomagnetic storms, and they are the true tempests of the edge of space. Storms that unfold in silence, yet leave the most distant consequences. Every 11 years or so, the sun enters a period of heightened activity known as solar maximum, when magnetic fields on its surface twist and snap, producing eruptions of energy that can dwarf anything the Earth has ever known. The most violent of these eruptions are coronal mass ejections, massive bursts of plasma and magnetic flux hurled outward at speeds exceeding 2 million kilometers per hour. When they are directed toward Earth, they can reach our planet in less than 2 days, compressing its magnetic field, distorting the upper atmosphere, and sending waves of energy racing around the globe. It is a strange kind of storm, one that cannot be felt by the skin or heard by the ear, yet it shakes the very space we live within. For most of human history, these events went unnoticed, their effects visible only as the shimmering auroras that spread across the poles. But as our civilization grew dependent on electricity and satellites, the sun's quiet fury began to reveal its true power. The first great warning came in September 1859, when an English astronomer named Richard Carrington was sketching sunspots through his telescope and witnessed a sudden burst of blinding white light. 17 hours later, the Earth's magnetosphere shuddered under the impact of a solar storm so powerful that telegraph systems around the world failed. In some offices, sparks flew from the lines, shocking operators. In others, telegraphs continued to send messages, even after being disconnected from their power sources, the induced currents running directly through the Earth itself. The night skies lit up with auroras so bright that people in the Caribbean could read their newspapers by their glow. It was the first recorded solar superstorm, now known as the Carrington event, and it remains the strongest geomagnetic storm ever observed. At the time, it was little more than a curiosity, a rare spectacle. But in the modern world, such a storm could cripple entire nations, knocking out power grids, disabling satellites, and erasing the delicate signals that guide airplanes, ships, and global communications. Since then, smaller storms have offered glimpses of what that future might look like. In March 1989, a powerful coronal mass ejection struck Earth and overloaded the electrical system of Quebec, plunging the province into darkness for 9 hours. The same storm forced satellites into temporary shutdown and disrupted radio signals across the northern hemisphere. Scientists estimated that the solar wind speed during the event reached over 700 kilometers per second. A gale of charged particles that no one could see yet everyone felt in some way. Even the Earth's magnetic poles wavered, shifting slightly under the magnetic pressure. As if the planet itself were reacting to the storm's unseen weight, in orbit the effects are even more direct. The thin layer of atmosphere that clings to the planet expands when heated by geomagnetic activity, increasing drag on satellites and forcing them to burn fuel to maintain altitude. Sensitive electronics can be short-circuited by energetic particles. Solar panels degrade, and communications systems experience bursts of static or complete silence. During the solar storms of 2003, sometimes called the Halloween storms, several satellites temporarily failed, including instruments on NASA's Mars Odyssey and ESA's Mars Express. Astronauts aboard the International Space Station retreated into shielded modules as radiation levels spiked, and airlines diverted polar flights to avoid interference with navigation systems. The storms lasted days, and when they subsided, the northern skies had glowed with color from Europe to Texas, a reminder that the Earth's protective magnetic field, though strong, is never completely still. To visualize such a storm is to imagine the unseen, A coronal mass ejection begins with the twisting of the sun's magnetic fields, tangled like ropes under unimaginable pressure. When they snap, plasma superheated gas composed of charged particles is hurled into space in a vast expanding wave. As it nears Earth, the planet's magnetic field acts like a shield, bending and trapping the incoming particles, forming long luminous tails on the night side known as the magnetotail. In that moment, the invisible barrier surrounding Earth ripples and folds, its lines of force shimmering like waves on water. Where these particles strike the upper atmosphere, oxygen and nitrogen atoms begin to glow, producing the aurora sribans of green and red light that flows silently across the polar sky. From space, these storms look like slow explosions of color, circling the poles in luminous ovals, the visible signature of a battle between solar energy and magnetic defense. What makes these events so haunting is their silence. Unlike hurricanes or earthquakes, there is no roar, no shudder of the ground, no sound at all. The energy that drives them moves through emptiness, through plasma and magnetic field, beyond the range of human senses. Only our machines, satellites, power lines, and sensors feel their touch. And only when they fail do we notice how vulnerable we are to the sun that sustains us. The storms remind us that the boundary between Earth and space is not a barrier, but a living, shifting interface. One that can tremble under forces we cannot see. Astronomers now monitor the sun constantly, using spacecraft such as NASA's Solar and Heliospheric Observatory, launched in 1995, and the more recent Parker Solar Probe, launched in 2018, which travels closer to the sun than any human-made object before it. These missions watch for the telltale signs of eruptions' sudden brightening. Shifting magnetic loops and the slow release of plasma send warnings to Earth when storms are on their way. Yet even with all our knowledge, there is little we can do to stop them. We can only prepare, waiting as we have always done for the weather of the heavens to pass. And still, for all their danger, there is something almost poetic in the way these silent tempests unfold. They remind us that even at the edge of space, where the air is gone and sound cannot travel, the universe remains alive with movement and energy. The Earth, encased in its magnetic cocoon, rides through that sea of invisible storms. And each time the solar wind collides with it, a faint ripple of light appears at the poles, a sign that we are protected, but not untouchable. In the quiet of the night, when the auroras rise and color the sky with their shifting curtains of green and red, it is easy to forget that what we are watching is the Earth's defense against a storm that has no sound. A storm that travels across the void like a wave of fire seen only through its reflection in our own magnetic skin. When humanity first began to send its creations beyond the last breath of Earth's air, there was an unspoken understanding that these small machines were more than instruments. They were messengers. Each carried not only sensors and transmitters, but a fragment of something deeper, something human, a need to reach outward, to be known, to leave behind proof that we existed. The edge of space was no longer a boundary to fear. It became a threshold, a door into the unknown through which we could send our voices, even if no one ever answered. In the long silence between stars, we have continued to speak. Not with words, but with symbols, sounds, and songs carved into metal and light, trusting that somewhere across the endless distance, someone might one day hear us. The first such message was simple, elegant, and impossibly hopeful. In 1972, as NASA prepared to launch the Pioneer 10 spacecraft toward Jupiter, a young astrophysicist named Carl Sagan proposed that the probe should carry a plaque, a kind of cosmic calling, card engraved with information about its makers. Working with artist Linda Salzman Sagan and astronomer Frank Drake, designed a small aluminum plate, just 15 by 22 centimeters, that would tell any finder, human or otherwise, who had sent it. The plaque depicted a man and woman standing beside the outline of the spacecraft itself, their hands raised in greeting. Behind them were lines radiating from a small circle, representing the sun's position relative to 14 pulsars whose frequencies were indicated in binary code, a celestial map that could, in theory, guide anyone who found the probe back to Earth. In the corner, a simple diagram showed the planets of the solar system. With an arrow tracing the path of the spacecraft outward from the third planet, it was at once scientific and poetic, a gesture of introduction, written in a language of mathematics and goodwill. When Pioneer 10 launched on March 2, 1972, it became the first human-made object to leave the solar system. A year later, Pioneer 11 followed, carrying an identical plaque, bound for Saturn and beyond. But it was in 1977. Humanity's most profound message to the cosmos was launched aboard two small golden travelers, Voyager 1 and Voyager 2. Designed primarily as scientific explorers, their mission was to study the outer planets Jupiter, Saturn, Uranus, and Neptune, but the engineers and scientists who built them knew they would eventually travel into interstellar space, leaving the warmth of the sun forever behind. And so, Carl Sagan and his team proposed something extraordinary, that each Voyager should carry a message from Earth, a record of who we were at that moment in time. The result was the Golden Record, a 12-inch gold-plated copper disc protected by a cover engraved with instructions on how to play it, including the same pulsar map found on the Pioneer plaques. The record contained 115 images and more than 90 minutes of audio, greetings in 55 languages, music from across cultures and centuries, sounds of wind, rain, thunder, heartbeats, footsteps, and laughter. It included Bach and Beethoven, but also Blind Willie Johnson's haunting blues, a Japanese shakuhachi flute, a Navajo night chant, and a field recording of Senegalese percussion. At its end was a message from then U.S. President Jimmy Carter, who wrote that the record represents our hope and our determination, and our goodwill in a vast and awesome universe. The images on the record were chosen with the same care as the sounds: a photograph of a woman nursing her child, a dancer from Bali frozen in mid-step, mathematical equations, diagrams of DNA, and the silhouette of a tree. The intention was not to explain everything, but to show that Earth was a place of variety and harmony, that we were a species capable of curiosity and kindness as much as invention. On August 20th, 1977, Voyager 2 launched first, followed by Voyager 1 16 days later. By 2012, Voyager 1 had crossed the heliopause, entering interstellar space and becoming the most distant object ever created by human hands. Its faint signal, still traveling homeward, takes over 21 hours to reach Earth, somewhere aboard it, spinning endlessly through the dark. The Golden Record continues its silent broadcast, a message without a listener, yet not without meaning. Not all messages to the stars have been physical. In 1974, 3 years before the Voyagers departed, scientists at the Arecibo Observatory in Puerto Rico used its vast radio dish to send a digital signal into space toward a globular star cluster called M13, located 25,000 light-years away. The transmission lasted just under 3 minutes, but carried within it a series of binary patterns that, when decoded, revealed the numbers 1 to 10, the atomic numbers of key elements in DNA, a representation of the double helix, a diagram of the solar system, and a stick figure of a human. It was called the Arecibo message, and though its destination was unimaginably distant, its purpose was the same as that of the plaques and records: to reach out into the silence and say, "We are here." Those radio waves are still traveling outward today, crossing the cold distances between stars, expanding into eternity like ripples in a cosmic sea. The question of what to say, and to whom, has always carried weight far beyond science. Each message sent beyond Earth reflects what we believe is most essential about ourselves. Do we define our world through music, mathematics, or compassion? Do we share our coordinates, or do we guard our silence? Some scientists argue that sending messages invites risks we cannot predict, that to announce our presence in a universe whose nature we do not yet understand might be unwise. Others argue that the act of reaching out is itself the defining mark of humanity, that communication is as vital as survival. Whether these messages are ever found is perhaps beside the point. They are mirrors as much as beacons, reflections of how we wish to be seen by others and by ourselves. It is unlikely that the Voyagers or pioneers will ever be intercepted. In another billion years, they will still be traveling through the void. Their surfaces scarred by radiation, their instruments long dead, yet their messages intact. Even when the Earth itself is gone, its continents worn away, its oceans vaporized by the dying sun, those small golden disks will continue to carry the story of a species that once looked up and wondered. When we send our voices into space, we are not merely asking if someone else is listening. We are reminding ourselves that we belong to something vast, that the edge of space is not an end, but an opening. In that infinite silence, our signals become like whispers in a cathedral, faint but enduring, carried on waves of light that may never find a listener, yet continue nonetheless because the act of sending them is, in its own way, an answer. When astronauts describe their first sight of Earth from orbit, their voices often change, softening in tone as though words themselves are inadequate for what they have seen. They speak of a planet that looks both infinite and impossibly small, of a sphere that glows with color, yet hangs in complete silence against a blackness so deep it seems alive. The phrase that returns most often is simple: a blue halo in blackness. That thin blue glower atmosphere is from below to stretch endlessly above us. Yet from the vantage point of space, it is revealed to be no thicker than the fragile film of breath upon glass. The realization is immediate and irreversible. For those who have seen it, the Earth is no longer just a place of nations and borders, of conflict and belonging. It is a single luminous home, adrift in darkness, a world wrapped in light so thin that it could vanish with the smallest wound: the International Space Station. Orbiting roughly 400 kilometers above the surface, has become the place where that view is most often lived rather than glimpsed. It circles the Earth every 90 minutes, completing 16 sunrises and 16 sunsets in a single day, each one painting the horizon in colors that no atmosphere-bound eye has ever truly seen. From the station's windows, dawn rises not in silence, but in an unhurried unfolding of color, a band of deep indigo giving way to a razor of gold, then a bloom of blue spreading across the curve of the world. Beneath that glow lies everything: oceans, forests, deserts, cities. Storms seen not as territories or possessions, but as one continuous pattern of living surface. The astronauts aboard the station often say that the longer they stay, the harder it becomes to think of the planet in pieces. The lines drawn on maps dissolve into rivers and mountain chains, and even the lights of cities, seen from the night side, merge into constellations of human presence that follow no boundary at all. The experience of orbit is one of constant motion. Yet paradoxically, it brings an overwhelming sense of stillness. Each time the station circles the planet, it passes over familiar places: Africa's deserts, South America's coasts, the swirling storms of the Pacific and Dietz time. They appear different, reshaped by weather, shadow, or the subtle play of light. The world below is both stable and endlessly changing, a reminder that what we call permanence is only movement viewed from too close a distance. At night, the view transforms completely. The land disappears, and only the lights of civilization remain threads along highways. Bright clusters where cities bloom, and faint glimmers where isolated villages mark their presence. Beyond them, there is the ocean, vast and black, its surface occasionally catching moonlight or reflecting the distant flicker of lightning within clouds. Above and beyond it all, the stars burn without twinkle or shimmer, each point steady and sharp, their ancient light untouched by air inside the station. Life continues in the rhythm of routine, experiments, communication with ground control, exercise, meals, the daily maintenance that keeps a small pocket of Earth alive in the vacuum. But outside those small tasks lies a deeper awareness, one that every astronaut describes in their own way. Yuri Gagarin, the first human to orbit the Earth in 1961, spoke of its overwhelming beauty, saying that he could not help but laugh for joy as he saw it. Decades later, American astronaut Katherine D. Sullivan, the first American woman to walk in space, said that looking back at Earth made her feel both proud and protective, as if she were seeing something fragile and dear. Others have spoken of awe mixed with a kind of sorrow, the recognition that everything humanity has ever known, every story, every love, every triumph and failure exists within that delicate sphere suspended in endless night. The farther they travel, the more that realization deepens, until the idea of separation itself begins to seem absurd. The station, though a triumph of engineering, is also a symbol of unity in its purest form. It was built not by one nation, but by many Russia. The United States, Japan, Canada, and the European Space Agency, each contributing modules, systems, and crews that must work together not as rivals but as companions. The result is a structure that exists entirely in cooperation, orbiting above the divisions that persist below. It is a fragile home made strong only by shared purpose. Inside, languages mix freely, experiments bear multiple flags, and meals are shared across cultures that once competed in silence. In that weightless environment, the usual measures of difference race. Politics geographied into irrelevance, replaced by the unspoken understanding that everyone aboard is, first and foremost, human. From that vantage point, the Earth itself appears borderless. There are no walls or fences visible from space, no lines of ownership or control. Even war, which on the ground feels immense and consuming, becomes invisible from orbit, hidden beneath clouds and the curvature of the horizon. What remains visible is only the truth of the planet's unity, the continuous swirl of weather, the flow of ocean currents, the rhythmic pulse of day and night. Astronauts often speak of this view as transformative, describing it as a kind of awakening. They call it the overview effect, a shift in consciousness that arises when one sees the Earth not as a collection of nations, but as a single, interconnected organism. From above, the atmosphere looks like a breath, thin and precious. And the realization that all life depends on that breath changes the way one understands everything below it. In those quiet moments between tasks, when the station passes through shadow and only the faint glow of instruments remains, astronauts sometimes press their foreheads against the glass and watch the slow sweep of the horizon. The Earth glows faintly in moonlight, its outline marked by the delicate blue of airglow. The same thin film that shields life from the radiation of space. Beyond it stretches blackness, pure, endless, absolute, and, within that blackness, the stars hang motionless, their light ancient and cold. There is no sound except for the soft hum of air circulation and the beating of one's own heart. It is in those moments, perhaps more than any other, that the meaning of the edge becomes clear. It is not a wall, not a final boundary, but a place of connection, where everything below and everything beyond meet in silence. When the station crosses into daylight again, the sun rises suddenly, flooding the cabin with light so bright it seems to erase shadow itself. The blue returns, the continents emerge, and the circle begins anew. The planet turns, the crew works, and every 90 minutes, the same miracle repeats. The sight of home hanging alone in the dark, surrounded by nothing yet filled with everything. From that height, the Earth's fragility is undeniable, but so is its endurance. The borderless night holds both the reminder that life exists only by a thread, and the hope that, even at the edge of the void, we remain bound together by that same thin line of light. There is a moment, somewhere above the last breath of air, and below the first whisper of the stars, when it becomes clear that the edge we have always sought does not truly exist. We have drawn it in charts and named it in kilometers, built machines to touch it, and sent our dreams beyond it. But what we call the border of space is not a line that can be crossed. It is a slow fading, a thinning of one world into another, a transition that has no single height, no precise beginning or end. The air does not suddenly stop. It only forgets how to carry sound. The sky does not darken all at once. It simply lets go of color until blackness remains. And the Earth, our home, does not end at its surface. It breathes upward into the void, sailing the faintest traces of itself far beyond where we can follow. What we call the edge is only the point at which our senses fail to keep up with reality. For centuries, people imagined space as something separate, vast, clean emptiness lying just beyond the reach of clouds. A place where the rules of Earth no longer applied. Pilots, balloonists, and later astronauts all spoke of crossing a threshold, of reaching the place where the blue turned black, where weight lost its meaning and silence became a substance of its own. Yet as our instruments grew finer and our understanding deeper, we learned that no such threshold exists. The atmosphere fades into space, the way twilight fades into night, each layer more transparent than the last. The troposphere becomes the stratosphere becomes the mesosphere, and above that lies the thermosphere and the exosphere, names given not to boundaries, but to gradients, places where air thins until it ceases to be air at all. Even beyond that, where the last atoms drift apart and Earth's gravity weakens, our planet still reaches outward. It's holding invisible ties that stretch far into the interplanetary dark. If we could stand in that upper silence and look down, we would see not a planet surrounded by emptiness, but a living system without clear edges. The atmosphere glows faintly with air glow and auroras. The magnetosphere extends in looping arcs that deflect the solar wind, and the trails of satellites form a thin, shining ring that marks humanity's presence like a halo of motion. Even farther out, the Earth's gravity continues to tug at dust, at fragments of rock, at the long, delicate tails of comets that pass too near. And still farther, at the point where the sun's influence begins to fade. The solar wind meets the pressure of interstellar gas, forming a shifting border called the heliopause. Beyond that lies the domain between stars. It's a vast and silent ocean through which the Voyager probes now drift, carrying within them the faint record of our voices. Yet even this, the so-called edge of the solar system, is not an edge at all. It is another transition, a gradient of energy, a place where the solar wind does not end, but merges with something greater. In truth, everything we have ever called a boundary in space is only a matter of perception. The Kármán line at 100 kilometers is convenient for records and definitions. But in the physics of the atmosphere, nothing special happens there. The Van Allen belts do not form walls, only regions of trapped particles. Even gravity, which we often imagine as a chain holding us to Earth, has no limit. It only weakens with distance, fading gradually until it is absorbed into the pull of other bodies. The universe, it seems, does not deal in edges, it deals in continuities. What we call borders are simply places where we decide to stop counting, where the change becomes too subtle for our instruments, or too vast for our minds. For the astronauts who have seen the Earth from orbit, this truth becomes more than theory, it becomes vision. From the windows of the International Space Station, the planet's thin blue outline looks so fragile that it seems almost to dissolve into the darkness. The air that sustains every breath is a transparent veil, film of color, only a few millimeters thick at that scale, separating all life from the vacuum beyond. Yet even that vacuum is not truly empty. It hums with radiation, with fields and particles that flow invisibly between worlds. To look down from that height is to see that everything is connected. Oceans feeding clouds, clouds feeding rivers, rivers feeding oceans again. To look up is to realize that the same is true of space. The magnetic storms that shape our auroras begin in the heart of the sun. 93 million miles away, the starlight that reaches our eyes began its journey before Earth even existed. The more we study this expanse, the less it seems like a void, and the more it feels like a great continuous sea. From the faintest traces of hydrogen in the upper atmosphere to the plasma of interstellar space, same laws move quietly through every layer. Energy flows, particles drift, light travels, and gravity whispers, binding everything into a single vast design. We are not separated from space. We are part of it, formed by it, carried within it. The boundary we imagine is only a comfort, a way to draw a line between the familiar and the infinite, between the small world of our lives and the enormity that surrounds it. But in reality, there is no line, leading the slow fading of one into the other. Like a breath that never truly ends, When we speak of crossing the edge, what we really mean is crossing into awareness of this truth. The balloonist who first saw the curvature of the Earth, the cosmonaut who first stepped into open space, the scientists who watched the faint signals from probes billions of kilometers away all have, in their own ways, discovered that the edge was never out there at all. It was within us, in the limits of our perception and imagination. To move beyond it is not to escape Earth, but to see it anew. To understand that the atmosphere, the magnetosphere, and even the interstellar winds are part of one long breath, one unbroken continuum of existence. And so the story returns to silence, to that place where the blue fades into black and the air becomes too thin to carry sound. There, in the hush between worlds, the Earth turns quietly beneath. The stars burn without flicker above, and humanity remains suspended in the middle, neither bound nor free, neither below nor beyond, but part of both. There is no edge, only a horizon that recedes forever, a boundary that keeps unfolding each time we reach for it. The sky breathes out into space, space folds back into the sky, and we, for a brief moment in the long history of light, hang between them witnesses to the infinite, watching the world exhale into the dark.